Hi everyone, my name is Deependra and I welcome you all in this one-shot video of quadratic equations. This is not just another one-shot video which you are watching on YouTube, rather this is that one-shot video in which we'll cover everything related to quadratic equations. From conceptual learning to all the theorems and the short techniques along with a lot of previous year's questions to consolidate this particular chapter, which will help you getting at least +4 marks in your examination. Because JEE Mains every year asks minimum 1 to 2 questions of easy to moderate difficulty level from this particular chapter. Along with this video, you'll get these handwritten notes along with the DPPs, that is the practice sheets. All of this is available to you on our PW app, link to which is already given in the description box. PW is an amazing app from where a lot of aspirants are preparing for different competitive exams at affordable prices. With that, without further ado, let's get started and begin our journey.
Before we start, let us understand what all we'll be discussing in this one short video, right? So we'll be discussing or talking about identities, that what are identities, some standard identities we'll learn. You will have this nostalgia that what all you have studied can be extended into completely different forms and be utilized in your JEE journey. And then we'll talk about some standard quadratic equations, discriminant, and then, the relationship between roots and the coefficients. And then we'll have this a very crucial result, Newton's formula. Trust me, every year a question is asked in every shift based on this either Newton's formula or location of roots. So these are the some really crucial concepts on which questions are asked. Then we'll talk about that what are the conditions, if two quadratic equations have common roots. So that will be discussed. Then we'll talk about graph of a quadratic equation, that what kind of parabola is formed, whether it will be upward or downward, or what will be its minima or maxima. So all that sort of things will be discussed during the discussion of graph. Then we'll talk about wavy curve method. It is not baby curve method, it is wavy curve method. Again, a very crucial concept which is used at a lot of places. Whenever you are dealing with inequalities, it is used. A very amazing concept. You'll be having very much fun with this particular part. Then you talk about location of roots, another very crucial concept, equally important as Newton's formula. Then we'll have a discussion on equations of higher degree as well. So we'll not just talk about quadratic only. It is a complete theory of equations in which we'll be discussing cubic, biquadratic, pentic, and a lot more. With that, without further ado, let's get started and discuss what are identities. Identities are very simple concepts, students. Let's say if you are given x plus 1 whole square minus whole of x square plus 2x plus 1 is equal to 0, and it may look like a quadratic equation, but if you pay attention to the details here, it is not a quadratic equation, this is an identity. If you look at the part where I'm saying that we know that x plus 1 whole square is equal to x square plus 2x plus 1. So if I subtract this from this, no matter what value of x is put here, this will result into 0 always. This will always result into 0. So what I'm trying to make you understand is, if there is an expression given to you and it is true for all the real values of the variable, which is x in this case, in its domain, then it will not be an equation, it will be an identity. Because it may look like a quadratic, it should have two roots, but if it is satisfied by more than two values of x, then it is not a quadratic equation, it should be an identity, which is true for all the values of x. For example, you have studied in trigonometry, sine square theta plus cos square theta is equal to 1. That's not an equation. Well, there is not a solution to it. And if you look at the solutions of that equation, there are infinite solutions because it is satisfied by all the real values of theta. Because sine square theta and sine square theta plus cos square theta is always 1, no matter what value of theta is put there. So identities are different from equations. They are true for all the values of x lying in its domain. I hope you are realizing identities are a very basic and simple concept, but they play a very crucial role in solving a lot of problems. For example, here, let's say there is a quadratic given to you, ax square plus bx plus c is equal to 0. Now we know we may see it as a quadratic equation. We may think that since it is a quadratic, it should have two roots. Which two roots? Alpha and beta, possibly. But if it is given, if it is told that this quadratic does not have two roots, it has more than two roots, Now that's a contradiction, right? If you are given a quadratic, it should have two roots. But if it is satisfied by more than two values of x, then how is that possible? Well, that possibly gets generated because this may not be an equation, rather this will be an identity, which will help me in understanding that this should be true for all the values of x. Now, mathematically, how can that happen? That, sir, whatever value of x is put here, it will result into a 0. Now, if you are using your common sense, very basic understanding, can you help me in understanding when can that happen? I hope most of you must have noticed, sir, if you keep a, b and c 0, if you keep a, b and c 0, no matter what value of x is put here, this expression will always be 0, because 0 into anything plus 0 into anything plus 0 will always be 0. Right, students? So I hope it makes complete sense that identities are different from equations. And I hope you're realizing the difference. I'll try and tell you with one more example, with one more definition so that you get it more clearly. For example, here, I have given you a biquadratic equation. It has a degree 4. It is given as ax to the power 4 plus bx cube plus cx square plus dx plus c is equal to 5x to the power 4 minus 3x cube plus 4x square minus 7x minus 9. And we are told that this is an identity in x. Now, if I am told that this is an identity in x, which means despite being quadratic, it will not have only 4 roots. It will have more than 4 roots. So if it has more than 4 roots, how can that happen? That can happen only when it is an identity, which is what we are told. And if it is an identity, the coefficients should be 0. That's the only way to make it happen. Now, how can you ensure that the coefficients are 0? If you have a is equal to 5, then 5x to the power 4 minus 5x to the power 4 will be 0. I hope you're getting it. If you are having b as equal to minus 3, if you are having c equal to 4, if you are having d equal to minus 7, and if you are having e equal to minus 9, I hope you're realizing all the terms will get cancelled, which means 0 is equal to 0, which means no matter what value of x is kept, this will always result into 0. So are you realizing the difference between an equation and identity? In equation, it has solutions, it has roots. But when it comes to identities, they have all the values of x. If it is an identity in x, then it will be satisfied by all the values of x in its domain. I hope you are understanding how are we segregating or differentiating identities from equations. Well, if you have understood this particular part, I'll try to make you understand some basic identities, then we'll solve a question on identity. Now, this is something you already know. First of all, do you know what is a plus b whole cube? We know that a plus b whole cube, when discussed, gives you a very important result, right? If I talk about a plus b whole cube, it should be a cube plus b cube plus 3ab times whole of a plus b, right? This is something you already know. But if I take this particular part to the other side, I'll have a completely different result. What will be that result? I'll have a cube plus b cube as one of the factors as a plus b and the other factor as a square minus ab plus b square. This can very easily be done when you shift this particular part to the other side. Now, how do I remember this? I have a very simple method, students. What I do here is that this plus and this plus here will always remain same. The next part is this sign and this sign are always opposite. Right? And these two signs, this sign over here and this sign over here, are always positive. Why are we discussing this? Because if I were to ask you another identity, a cube minus b cube, your response should be, sir, a minus b, because these two signs should be same. The other part will be a square plus ab plus b square, because a square and b square are always positive, and this sign are always opposite. So this is how I usually remember it. So I hope you will learn it and remember it. Along with this, there are some more identities. Now, what are those identities? Let's have a look at that. Another very crucial identity is having a cube plus b cube plus c cube minus 3abc in mind. This is again something very crucial, students. Now, why is it a very crucial identity? Because first of all, a cube plus b cube plus c cube minus 3abc is either a plus b plus c times a square plus b square plus c square minus ab minus bc minus ca, or if I multiply this part by 2, of course it is an equation, so if I'm willing to multiply this by 2, I am supposed to divide it by 2. So if I'm multiplying and dividing it by 2, I am keeping that division part 2 outside and multiplying that 2 inside. The result which I'll be getting is, I am writing that result here, just pay attention to the details here. If I multiply that part here, so I'll be having this a plus b, I'm really sorry, I'll be having this a plus b plus c whole divided by 2, because I have divided it by 2, but I'm multiplying it by 2. So when you multiply it by 2, what will you have? The result will be 2a square plus 2b square plus 2c square. Then I'll be having minus 2ab minus 2bc and minus 2ca. That will be the result I'll be having. Now, what is the advantage of this? Why did we do it? Now, if you pay attention to what I'm asking you, then can you not say this part is kept outside intact? But if you look at 1a square from here, 1b square from here, and minus 2ab from here, can you not have a minus b whole square? Then if you take 1b square from here, 1c square from here, and minus 2bc from here, can you not have b minus c whole square? And similarly, if you take the remaining a square from here, remaining c square from here, and minus 2ca from here, then another identity will come into picture, c minus a whole square. Which means, if I were to write in a completely different format, can I not have another version of this identity? Let's say I try and make you understand that particular part here, when I'm given that x cube plus y cube plus z cube minus 3xyz. This is exactly what we were given here, but with different variables. Well, in that case, it will be x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx, which is what we were given already. But if I multiply and divide it by 2, I'll have another conclusion, 1 by 2 x plus y plus z, but then whole of x minus y square plus y minus z square plus z minus x square. So I hope this part makes complete sense in your brain. Along with that, this particular identity is a very crucial one, a very simple one. We will need it, so remember it. If you are having xy plus ay plus bx plus ab, then I hope you are seeing, I will take y common from here, then I'll be left with x plus a. I'll take b common from here, then again I'll be left with x plus a. So here I was left with y, here I was left with b. So I'll having two factors, y plus b and x plus a. A very simple factorization, splitting the middle term, somewhat like that only. Then we already know this particular part. Let's learn this particular part where if I'm given x plus y plus z whole square, then I'll be writing it as x square plus y square plus z square plus 2xy plus 2yz plus 2zx. These are some very basic identities. I am constantly requesting you to take a screenshot of it and keep it with you, because these are the identities which will be used throughout your journey. So remember them, learn them, memorize them, by heart them, because this is something which you need to remember. These are the results which are used almost in all sorts, all category of questions. You may need them anywhere in your JEE preparation. Along with this, there is a very crucial result, which is something very handy and it should be kept, because this particular result, which I'm going to tell you now, is used even in inverse trigonometric function, in sequence and series, and a lot more places. What is that result? Even in indefinite integration, and with a lot of chapters, this particular result is used. For example, if I'm having m to the power 4 plus m square plus 1, this particular result I'm having, right? Now, why did I do this? This part is very simple. Why are we doing it further? Why are we solving it further? But let's say I want to keep it factorized. I want to, use it in a different format. Then how do we do that? See, this particular m to the power 4, I'll write as m square whole square. Then this m square I'm writing as 2m square, but of course I have made some changes. So 2m square, if I have written it as, then I'm supposed to subtract another m square, which is what you all know. Then I'll be having this plus 1 here, and then I'm subtracting an m square here. So I hope the equation is still intact. It is still balanced. It is exactly what we were given. M to the power 4, 2m square minus m square is again m square, and this is 1. Why are we doing it? Now, I am asking you to pay attention to this particular part. What is it? Can you not see it as a square plus b square plus 2ab, which means it should be a plus b whole square. So it should be a, which is m square, plus b, which is 1 whole square. Then what am I left with? I am left with m square. So I am writing it as m square. Now, sir, what is the point of doing all this? Why are you actually doing this? The reason is very simple. Are you not seeing it as a square minus b square? Some of you, I am sure, must have noticed it. So if it is a square minus b square, I'll be using another identity, a plus b times whole of a minus b. So you'll be getting a plus b as a, which is m square, plus 1 plus b, which is m, and a minus b, really sorry, a minus b will be m square plus 1 minus m, right? Now, if I were to simplify this, this is exactly what we are given here. If you just pay attention to this particular part, where I'm asking you x to the power 4 plus x square plus 1. Well, it will be x square plus x plus 1 and x square minus x plus 1. Remember it, by heart it, memorize it. This is a very important identity, one of the most crucial identities. Learn it, please learn it. This will be used at a lot of places. Whenever you see something like this is given to you, you should have this idea in your brain that this can be factorized into this and this will be used as per the need of the question. Remember it. Then of course we have two very crucial results. What are these two results? Please understand. I'll try to make you understand this with a different example here. Let's say if I am asking you x to the power n minus y to the power n when divided by x minus y, what will be the remainder? What will be the remainder when x to the power n minus y to the power n is divided by x minus y for any natural value of n, where this small n is a natural number. So what will be the remainder? Always remember, x to the power n minus y to the power n has a factor x minus y. It always has a factor x minus y. So when it comes to finding the remainder will be 0. Vice versa. What I'm trying to make you understand here is that if you have x to the power n minus y to the power n, where n is any natural number, it is written as x minus y times x to the power n minus 1, x to the power n minus 2 into y, x to the power n minus 3 into y square, and so on. Remember this as a result. And if you look at this particular result, this is something which you may be thought of, What is it? A cube minus b cube. Something similar to x cube minus y cube, which was x minus y. X square y, I hope you're realizing x square, then of course you will not be having this term. I'll try and make you understand here by writing it here. See, what do we have here? We have this particular part where I'm asking you to write a cube minus b cube by using this particular part. So we'll be having a minus b first of all, I hope you're realizing, and the other factor will be, see, here we have this power n minus 1. So we had this a cube, so I'll be writing a square. I hope you're realizing that. Then power will diminish, the powers of a will diminish and the powers of b will increase. So here there was no b, but then power of a will get decreased by 1 and power of b will get increased by 1, because here power of b was 0. Then power of a will again get decreased by 1, which will make it 0, but power of b will become 2, and that's it. So that's what I'm trying to make you understand. So if I'm given x to the power 5 minus y to the power 5, how will I deal with that? With this particular identity. So I hope you are understanding. That's a very crucial result which you should remember in your brain, that this is how we deal with it. Next part is even crucial, that if you are having x to the power 2n plus 1 plus y to the power 2n plus 1, and if I say where n is a natural number, so whenever I mention 2n plus 1 and 2n minus 1, I hope you have this thing in mind, that it will make it an odd number. If n is a natural number, 2n plus minus 1 are always odd. Which means if this expression is divided by x plus y, it will also generate a remainder 0. I hope the result is understandable. It's very simple. Why will it generate a remainder 0? That's again a very simple part which can be understood by this particular portion given over here. X to the power 2n plus 1 plus y to the power 2n plus 1 will be factorized as x plus y one of the factors, and the other factor will be again somewhat like what we have already discussed. But here again, what you need to understand is sign, the plus minus sign will keep on changing alternatively, which means it will begin with x to the power 2n. Then I'll have x to the power 2n plus 1 into y. Then I'll have, sorry, it should not be plus 1, it should be 2n minus 1. So there is a small correction here, students. Please understand. This over here should be basically minus 1, right? This should not be plus 1. So always remember this should be 2n minus 1y, then 2n minus 2. So again, power of x are getting decreased, powers of y are getting increased, and plus minus sign is getting changed alternatively. That's a result which you should remember. Again, another very crucial identity, if you are having this particular part, which part, students? X plus y plus z whole cube. Well, that will be taken as x cube plus y cube plus z cube, first part, then 3 times x plus y, y plus z, and z plus x. Trust me, I am constantly repeating that this is something you should be aware of. You should learn all these identities. Some of the most important identities are brought into one page and clubbed together. Remember them. This is something very crucial. You should have them at your fingertips. This is something very important we'll be using throughout our journey. Now, if I proceed further, if I move ahead, there is something very interesting comes in front of us, which is nothing but the question we'll be discussing now. A very interesting question, a very simple question, which will check a lot of concepts you have learned so far. So before I solve this question, I request you all, give it a try, and then we'll discuss its solution together. I hope you can see that data is very important, that how do you interpret the problem, it is what more important, because comprehension of the question is something which plays a very crucial part. Einstein has said it, that I spend most of my time in understanding the problem, because the moment you understand the problem is solved. I hope you're getting my point very clearly, that we are told that this equation, which looks like a quadratic in x, is satisfied by more than 2 values of x. Now, I hope you're realizing, if somebody is saying that this is a quadratic in x and it is satisfied by more than 2 values of x, then it cannot be an equation. It has to be an identity. And when do you treat it as an identity? Well, sir, the coefficients should be 0. That's it. You have cracked the logic, you have understood the problem. Now all you need to do is solve it, which you know how to, right? So I'll begin with this particular part. When I say, sir, if I have understood, if I am aware that this is not an equation, this is an identity, the coefficients must be 0. So what is the first coefficient? The first coefficient is lambda square minus 5 lambda plus 6. This should be 0. And along with this, the second coefficient lambda square minus 3 lambda plus 2. This should be 0. And along with this, the third coefficient lambda square minus 4. This should be 0. If all of these become 0 simultaneously, then I'll have these x square plus x plus something constant will be 0 for all the values of x. That's exactly what identity means. So how do I solve it further? The solution is very simple, students. I need to solve these 3 quadratics and find a common solution. I need to find a common solution. I hope you're realizing why. So I hope you know how to split this particular part. So 5 lambda, you have minus 5 and plus 6. I need 2 numbers which when multiplied give you plus 6 and when added give you minus 5. Do you have those numbers? I hope we all have. It should be lambda square minus 2 lambda minus 3 lambda plus 6 is equal to 0. Now there comes a very interesting part. Don't factorize it further. You can directly write your roots from here only. What are going to be those 2 roots? Please first of all write these 2 numbers. So we have these 2 numbers, minus 2 and minus 3. When you split the middle term, you get 2 numbers, minus 2 and minus 3. You write the negative of these numbers. So negative of these numbers, minus 2 and minus 3 will be 2 and 3. The job is not done yet. Then after writing the negative of these splitted middle terms, you divide them by the coefficients of this lambda square. You divide them with the coefficient of lambda square. The coefficient of lambda square is 1 here. So the value of lambda will be 2 upon 1 and 3 upon 1, which are 2 and 3. Did you understand this part? Let's apply this particular part here. and tell me by writing in the comment box how many of you are understanding this and are you able to crack the roots of this particular quadratic. So yes, if I look at this particular quadratic, it should be lambda square minus 2 lambda minus lambda plus 2 is equal to 0. I hope most of you must have cracked it. I need minus 3 as a sum and plus 2 should be the product. From here, the roots are going to be negative of minus 2 and negative of minus 1 will be 1 and 2, and I need to divide 1 and 2 by the coefficient of lambda square, which is 1. Hence, it is going to be 1 and 2 only. Well, when I'm given lambda square minus 4 is equal to 0, I know lambda square is equal to 4, and in that case, lambda will be plus minus 2. Lambda will be plus minus 2. So I have having two answers from here, two answers from here, two answers from here, but these are not 6 answers. Well, actually, what you need to understand is that you need to find those values of lambda for which this, and this, all of them are 0 simultaneously. Are you getting this particular part? Which means if I have this 2 from here, if I take this 2 from here, and if I take this 2 from here, then only I can ensure that all of these coefficients will become 0. Did you get my point? Because if I put 3 here, this will become 0, but these two won't become 0. So I hope you're realizing the only value of lambda which will keep all of them 0 simultaneously is 2. So from here, my answer will be 2, which is the intersection of these three answers. I got two values from here. I got two values from here. We got two values from here. But what I'm supposed to do is, I'm supposed to take the intersection of these 6 values, or rather they were actually not 6, they were actually 1, 2, 3, 4. So out of these 4 values, pairwise if taken, then there was 2 common among all of them, which is the final solution. Tell me honestly, how many of you were able to think like this? Tell me honestly, how many of you have done this particular part already? I hope you are understanding that in this one shot, we'll cover this entire chapter. Just stick to it, learn all the concepts one after another, and you will get all the details very easily, and you will understand the entire chapter with this one shot if you know the basics. Now, I'll proceed with the part further, and let's start understanding what is a quadratic equation. We know quadratic is basically ax square plus bx plus c is equal to 0, where you need to understand that ABC can be any real number, and if it is a complex quadratic, then ABC can be any complex number. So whether it is a complex quadratic equation or a real quadratic equation, what you need to understand is that A should never be 0. That's the most crucial part, because the coefficient of x square has to be non-zero. Because if A becomes 0, it won't be a quadratic, it will become a linear then. So you need to ensure that A should be non-zero. Along with this, splitting the middle term is what we already know. But if I don't have splitting the middle term, can I use another method? The formula given by Acharya Sridhar, a very simple formula, minus b plus minus under root d upon 2a. That's the formula we use for solving quadratic equations. We already know this. But if I were to ask you what is d, well, we all know that d is the discriminant, which is given by b square minus 4ac. So remember this as a result, that discriminant is b square minus 4ac. Now, if you have this particular part inside the under root, a lot of things are getting decided now. What do I mean by that? Please understand, b square minus 4ac is lying inside the square root sign. So a lot of things are getting decided. Why? Because you are realizing this particular part, that because of this d, nature of roots will get decided. Before I talk about nature of roots, can we solve a question asked by JEE Mains in 2025? I am trying to make you understand that very basic question based on quadratic formula. Trust me, not even a quadratic formula was asked by JEE Mains in 2025. So there are always questions, easy, moderate, tough. You need to learn, you need to identify and then solve them. For example, this one, look at this particular question, a very easy, very simple, just understand the language of the question. Number of solutions are what we are asked. So we not even find the exact solutions. We may be able to, but we are supposed to find the number of solutions of this particular equation. Now that's a very difficult equation, I think, because under root sign is there. I don't know how to solve that, sir. Even if I take the LCM, a lot of ambiguities may arise. So let's not bother about that. Can we say, let's say, sir, that this 1 by root x I am treating as t here. Can we treat this 1 by root x as t here? We all can. So if I'm treating this 1 by root x as t, what transformations I am bringing to this particular equation? Well, if I am having 1 by root x as t, I need not tell you that 1 by x will be t square. Did you all get that part? Were you all able to crack this particular part? Now, what do I do next? 9 upon x, I hope you can see, should be 9t square. Minus 9 upon under root x, I hope I need not tell you, will be minus 9t plus 2. Then the other factor will be 2 upon x, I hope it should be 2t square. Then I have 7 upon root x, which should be minus 70. Then I have a plus 3 from here, and it should be the particular solution. Now, how do I proceed with it? Because this is what we already know how to solve. Two quadratics are given. Product of them is 0, which means either this will be 0 or this will be 0 or both will be 0. I'll simply factorize it. So again, I see 9 into 2 is 18. 18 can be brought with minus 6 and minus 3 because minus 9 is given. So I'll be writing it as 9t square minus 6t minus 3t plus 2. Then the other factors from here will be 2t square. Here I need 3 into 2, 6. And here I'm given minus 7. So I think minus 6 minus 1, because sum will be minus 7 and product will be plus 6. So 2t square minus 6t minus t plus 3 is equal to 0, right? So this is what we know so far. Now, what I do next is, the part is very simple, because we know if I put this product or factor equal to 0, what will I get? I'll get two values of t. What are going to be those two values of t? From this factor, I'll get two values of t. One of the values will be, I hope you know how to crack the value of t. I hope you know how to look at the value of t. The short technique we have learned. Negative of minus 6 will be plus 6. And that plus 6 should be divided by coefficient of t square, which is 9. So 6 upon 9. And we know 6 upon 9 is basically nothing but what? 2 by 3. So can I write a 2 by 3 here? Then I'll have another value. What is that? Negative of minus 3 upon 9. So minus of minus 3 upon 9, which is 3 upon 9. And 3 upon 9 is basically 1 by 3. So these are the two values of t I have received from here. Now, other two values of t which we may receive from here would be, please understand, minus of minus 6 upon 2. I hope you have understood it. So minus of minus 6 upon 2 will be 6 upon 2, which will be 3. Again, another value which I'll fetch from here is minus of minus 1 upon 2, which will be 1 upon 2. And I hope you're realizing this should be 1 by 2. Now, we have cracked the values of t. Can I not crack the values of x now? But I need not find the values of x. I need to tell that what are the number of solutions. What is the number of solutions? All you need to here understand is that there is a catch here. Some of you are wanting to suggest that, sir, you even need not find this. In that case, you may be wrong. Please understand. Let's say if somebody is wanting to say, sir, I am looking at this quadratic and I am looking at this quadratic. And by looking at these two quadratics, I can sense that their discriminants are greater than 0. Which means they will be having two distinct roots each. This will be having two roots. This will be having two roots. And then finally, you will be having 4 roots. Please understand that may be true for the value of t. But when it comes to finding the x, there is a catch. Let's say, for example, this question appears or comes up with an answer minus 3 here and plus 3 here. I hope you're realizing it. But when I square minus 3, I'll get 1 by x as 9. When I square 3, I'll get 1 by x as 9. So whether it happens to be minus 3 or plus 3, it would have given me the same value of x. And that's where your number of roots may have narrowed down. Are you realizing the problem? So that's where I need to understand that if I'm having 4 distinct values of t, even when squared remains distinct, I'll be having 4 distinct values of x. I hope you're understanding here. If 1 by x is t square, x will be 1 by t square. So if I square them and take their reciprocals, I'll have the values of x. So from here, I'll be value of x as 2 by 3, 4 by 9, take reciprocal of it, 9 by 4. 1 by 3, square is 1 by 9, take reciprocal of it, 9. 3, square is 9, take reciprocal of it, 1 by 9. The other part 1 by 2, square it 1 by 4, reciprocal is 4. So I can very clearly see that I'm getting 4 distinct values, and hence the number of solutions are 4, although you need not find the values of x. From this part only you could have concluded, yes, these values when squared and when the reciprocals are taken will not generate some same values. And through that, we could have clearly answered this question that in this particular case, the number of solutions will be 4. The number of roots will be 4. I hope this part is very well understood by you all. Proceeding ahead, let's have another look at the another part where I'm going to make some comments on the nature of roots. Now, what do I mean by nature of roots? We already know that if you are given a quadratic, and I'm talking about a real quadratic equation where ax square plus bx plus c is equal to 0 is given, and a, b, c, the coefficients are real. I'm not talking about complex quadratic equation. So if a, b, c are real, of course a should not be 0. Then the conclusion about the roots boils down to the simple fact, discriminant, that what is the value of discriminant? This b square minus 4ac, right? That's your discriminant. I hope you already know. So if you have this discriminant b square minus 4ac, it will be either less than 0, greater than 0, or equal to 0. If it is greater than 0, under root over d will give you something real, which means roots will be roots will be non-equal, distinct, but real. I hope you are getting it very clearly. If d is greater than 0, then roots will be real and distinct. But if d is negative, b square minus 4ac turns out to be negative, under root over a negative number will give you something imaginary, will give you something complex. Well, in that case, whenever the discriminant is negative, the roots are said to be complex. And there you say that the roots are again complex. And of course, there is no sense of comparing the complex numbers. So there is no point of saying whether they'll be equal or distinct or not, but they'll be complex. So what I'm trying to make you understand is that if you are having a quadratic, somewhat like, let's say, ax square plus bx plus c is equal to 0, and later on it is found that its discriminant was negative. It was a real quadratic. A, B, C were real. This is what I'm told. And if discriminant is negative, well, in that case, if one of the roots is p plus iota q, then the other root is going to be p minus iota q, which means roots exist in pairs and they are conjugate of each other. So if one of the roots is p plus iota q, the other root will always be p minus iota q, given or provided that this is a real quadratic. If it is a complex quadratic, then this may not be true. I hope you are getting my point very clearly. Same holds true if you are getting irrational roots. I repeat, that logic is again very simple. Let's say there is again this particular quadratic you are dealing with, ax square plus bx plus c is equal to 0. This is what you're dealing with. But let's say that in this quadratic, of course, I'm told that a, b, c all are rational numbers. I hope you know what are rational numbers. 2, 3, 4, 7.5. Such numbers are rational numbers which can be expressed into p by q form, but under root 2, under root 3, the decimals which are neither terminating nor repeating are irrational numbers. So what I'm told is that these are 3 rational numbers. And I am also aware of one particular fact, that discriminant is greater than 0. So if I know that the discriminant is greater than 0, can I say that it will be a quadratic which will be having 2 real and distinct roots? 2 different roots I'll be getting. So let's say one root is alpha and one root is beta. Let's say I know that d is greater than 0, but it is not a perfect square. D is not a perfect square, let's say, for a while. So if d is not a perfect square, can I not say I'll be having irrational roots? Because let's say if I'm given d as 9, so square root of 9 will be 3. But let's say if d happens to be 11, then you will have under root 11 as, here in the formula, minus b minus root 11 and minus b plus root 11 upon 2a. Well, in that case, that's a problem. Well, it's not a problem. The only fact which is needed to be understood here is that in this case, the roots will be irrational, because under root 11 cannot be simplified further. So when roots are irrationals, they also exist in pairs. For example, if one of the roots is p plus root q, then the other root will be p minus root q. I repeat, this is true only when a, b, c are rational. If A, B, C are irrational, and if one of the roots is irrational, then the other root can be anything, rational or irrational, that cannot be said. This holds true only when A, B, C are rational. I hope you're getting this part very clearly, that if the discriminant is negative, roots are imaginary. If the discriminant is positive, roots are real and distinct. And if the discriminant is zero, D has become zero. And if D has become zero, I hope you're realizing very clearly that this part will become zero. And if this part becomes zero, this part has no role to play at all. Then this will be minus b by 2a or minus b by 2a, which means roots are real, but they are same, they are equal. So if you are having d is equal to 0, the third conclusion, then both of the roots are going to be equal, and that is minus b by 2a. Something additional which you need to remember is students commit an error that they write ax square plus bx plus c as x minus x1 into x minus x2 if the two roots are x1 and x2. That's wrong. Because if you don't write this a here, and if you write it as x minus x1 into x minus x2, then x into x will generate x square. But on the left hand side, you are having ax square. So where did that coefficient go? That's a problem. So always remember, x minus x1 into x minus x2 should have this coefficient of x square a along with them when you factorize them, when you write as product of these two factors. I hope you're getting it very clearly. Similarly, let's say when d was 0, when the discriminant was 0, the two roots were minus b by 2a, same. So in that case, I can write this quadratic as x minus x1 whole square. No, wrong. That's false. What I need to do is, I again need to introduce the coefficient of x square, which is a here. So whenever you're willing to write it as a product of the factors, then you need to take care of this a. That's a very silly error students commit. In a rush, students crack the roots alpha and beta. And once they crack the roots alpha and beta, they simply write it as x minus alpha into x minus beta, which is wrong. If you are willing to write your quadratic expression as x minus alpha into x minus beta, you need to ensure that the coefficient of x square remains intact by introducing this particular a here and here. I hope this part is very well understood by all of you, that why am I constantly repeating this portion. With that, let's proceed further and understand it in a more detailed format, that what all gets revealed further. One more very crucial result you need to understand is that, let's say you're given this quadratic ax square plus bx plus c, right? So this is what you're given. And here you're told that this result, there is a given result to you which says that, let's say, if I am told that a plus b plus c is equal to 0, somehow I could see, or I could find that a plus b plus c is equal to 0, then what additional conclusion can you draw from here? Let's say if the sum of the coefficients a, b and c is 0, can you not say that, sir, in that case we can always say that one of the roots is going to be 1. Did you get that? Was anyone able to think of like this? Please understand, if I replace x by 1, it will be a plus b plus c. I hope you're realizing. And similarly, if I say a minus b plus c is equal to 0, then one of the roots will be minus 1. Because if I replace x by minus 1, it will be a minus b plus c is equal to 0. So such conclusions can be drawn based on your common sense or understanding or observation skills. Along with this, we already know, let's say if the other root is beta, then what we know is that the product of the roots is c upon a. So alpha into beta will be c upon a. But if alpha is 1, alpha into beta, yani 1 into beta, that should be c upon a. So that's my point. That's my another point, that if you are given that a plus b plus c is equal to 0, then you can always say that one of the roots will be 1 and the other root will be c by a. I hope you are getting why. Well, with that, let us proceed further towards the next part, where we discuss what is the relationship between roots and coefficients, because this is something which now will help us in clubbing the higher degree symmetric forms of roots. For example, if I were to ask you a value alpha square plus beta square, or if someday in some question we have to deal with alpha to the power 4 plus beta to the power 4. So how are we going to draw those results? That is exactly what we'll be discussing with this particular part, where we are laying this foundation here. So we know that the sum of the roots is always minus b upon a. This can be drawn by comparing the coefficients. We know that if on the left hand side you are having the quadratic as ax square plus bx plus c is equal to 0. And on the right hand side, if the quadratic is a times x minus alpha times x minus beta, right? If it has two roots, alpha and beta. Well, we know that sum of the roots is always going to be, if you compare just the coefficients of the x square on the left hand side and the right hand side, coefficient of x on the left hand side and the right hand side, coefficient of the constant terms on the left hand side and the right hand side, you will get these results. So first result will be sum of the roots denoted by s, alpha plus beta is given by minus b by a. Product of the roots alpha into beta, which is given by c by a. Well, there is one more result. Now, what is that result? Please understand that result is even interesting. How do we get that result? Let's discuss that conclusion first. Can someone help me with this particular part? How do we find the difference of the roots? Can you help me with that? Let's say if I were to ask you what will be the value of alpha minus beta square. Can you help me with that? Can I not think that alpha minus beta square could be alpha plus beta whole square minus 2 alpha beta? Why did I say so? Because this will be alpha plus beta square, then minus 2 alpha beta. I'm really sorry, that is the value of alpha square plus beta square. It should be minus 4 alpha beta. So I should write a minus 4 here. I'm really sorry. That was the expression for alpha square plus beta square. So alpha plus beta whole square will give me alpha square plus beta square plus 2 alpha beta. But out of that 2 alpha beta, if I subtract minus 4 alpha beta, I'll be left with alpha square plus beta square minus 2 alpha beta, which is alpha minus beta whole square. I hope everybody must have cracked it. Now, with that, what is the conclusion? Why are we doing all this? Is someone able to think like this, that to get this, the difference of the roots, this is a very appropriate method. Why so, students? I hope you are cracking it very clearly that on the LHS, if I'm having alpha minus beta whole square, then on the RHS, alpha plus beta minus b upon a. When squared gives you b square upon a square, right? Minus 4 alpha beta. Alpha beta is c upon a. So it should be minus 4 c upon a. Now, if I take the LCM, I hope you know I need a square here. So I'll multiply this by a and I'll divide it by a. I hope you can see it very clearly that here I'm having alpha minus beta whole square is equal to b square minus 4ac upon a square. I hope that's a very crucial result we have drawn. Because if I take the under root on both these sides, I'll have a result plus minus root over d upon a. But a should not be just a, it should be mod a. Why? Because the result is very simple, students. If I wish to find alpha minus beta, or if I just take the mod here on the left hand side so that I can get rid of that plus minus sign, I'm supposed to take the under root here. So when I take the under root here, b square minus 4ac we know is discriminant, right, students? So it should be under root over d. But here there is another catch here, students. Let's say if I were to ask you the value of under root x square. If I were to ask you the value of under root x square, can you help me with this value? If you are thinking the value of x, the value of under root over x square is x, then you are absolutely wrong. The value of under root over x square is not x, it is mod x. Why so? Because if I were to ask you under root over minus 2 square, will you say plus 2 or minus 2? It has to be under root over 4. Or under root over 4 means what? 2. Under root over 4 does not mean minus 2. So I hope you are not saying that this square and square root are nullified and you're left with minus 2. No. Under root over x square is always mod x. So if I put under root over a square, it should be mod a. So that's the another result which you're supposed to remember or learn, that difference of the roots, which you say mod over alpha minus beta. Mod we are putting because we are saying that greater root minus lesser root. That is what we are concerned about. We are concerned about the difference. We are not concerned about the sign. That's exactly the modulus sign does, right? So we are saying that the difference of the roots is always going to be under root d upon mod a. I hope you can see it very clearly happening over here like this. Now this symmetry helps us in understanding some different versions of these alpha and beta, that how do you deal with them. First of all, let us understand what is symmetry. Symmetry means if I am told that there are two roots, alpha square beta and alpha beta square. Now what do I mean by that? That there is a quadratic which has roots alpha square beta and alpha beta square. Then these two roots are symmetric in nature. Why am I saying symmetric in nature? Because symmetry means if I replace alpha by beta and beta by alpha and vice versa, of course, then they will not lose their originality. The roots will still remain same. Sir, what is the point of understanding symmetry? Trust me, questions based on symmetry are asked by JEE Mains and Advanced. So, when you deal with questions based on symmetry, these are the formulae which help you in dealing with those questions based on symmetry. So, first of all, I hope you have understood what is symmetry. If I replace alpha by beta and beta by alpha, here I'll get beta square alpha, and here I get beta alpha square, which is exactly what I originally had. I hope you are realizing that the roots have not changed. So if you are replacing alpha by beta and beta by alpha and the roots have not changed, then we say that the roots are symmetrical in nature. And these are the perfect example of those symmetries. Now, why are we discussing this? Because questions are asked where you have to deal with these values. Sometimes alpha cube minus beta cube, sometimes alpha to the power 4 plus beta to the power 4. So how do you deal with these values? That's exactly what will be learned in this particular part of this video. Let's have a look at this particular part, students. Alpha square plus beta square. I hope easily understandable. I'll have alpha plus beta whole square, which will be alpha square plus beta square plus 2 alpha beta. But out of that plus 2 alpha beta, if I subtract 2 alpha beta, I'll be left with alpha square plus beta square only. Understandable, I believe. Need not be explained. Next part. Similarly, alpha square minus beta square. So let's say there is a quadratic. I am given in a question and I'm asked to find alpha square minus beta square. So if I know alpha and beta, or even if I don't know alpha and beta, can I crack alpha plus beta? Sum of the roots. Can I crack alpha minus beta? Difference of the roots. And if I take the product of sum of the roots and product of the roots, can I not crack the value of alpha square minus beta square? So these are the concepts I'm trying to help you with, that for example, if a question asks for any sort of these values, how can you reach to them? How can you approach them? How can you deal with these kind of values? So I'm just giving you the hint. That is again can be treated as a cheat sheet. You can take the screenshot, keep this particular part with you, although the entire PDF will be provided to you. But this is again a cheat sheet which you should memorize, which you should learn, which you should by heart. Please understand, there are certain things which if you learn will actually help you in saving a lot of time in the real examination hall. Abraham Lincoln has once said that if you have 6 hours to cut down a tree, spend first 4 hours in sharpening the saw. It is same as sharpening the saw. If you learn these formulae, if you learn these identities, if you learn these methods, they'll actually help you in writing alpha to the power 5 plus beta to the power 5 very quickly, because you will have this result with you. Even if you don't remember them, understand them. You will derive it. But please understand, deriving will be more difficult. Again and again doing this entire process in the examination hall will be a little tough. So I will strongly emphasize or urge or insist that up to this 6th identity, you should have them at your fingertips. That is something you should be aware of. Now, let's have a look at this particular part. If I am asked to deal with alpha cube plus beta cube, we already know that alpha plus beta whole cube is alpha cube plus beta cube plus 3 alpha beta times alpha plus beta. So can I not say that alpha cube plus beta cube will be this part minus the additional part which was there? Now, why are we dealing with this part only? Because if I'm asked alpha cube plus beta cube, I know what is alpha plus beta. I know what is alpha plus beta. I know what is alpha into beta. So I know sum of the roots and the product of the roots. So I'm trying to write all these values on the left hand side in terms of sum of the roots and product of the roots, which we already know, which we are already aware of. For example, if I were to ask you alpha cube minus beta cube, now I hope you must have cracked it. And if you have done it, do write in the comment box that, sir, it should be alpha minus beta whole cube. Alpha minus beta, difference of the roots, we have cracked it, under root d upon mod a. Remember it, remember it. Tell me honestly, how many of you were aware of it? We all know what is sum of the roots. We all know what is product of the roots. How many of you were aware of difference of the roots? And if I'm asked alpha cube minus beta cube, it should be alpha minus beta whole cube plus 3 alpha beta times alpha minus beta. This is the difference of the roots, and this is the product of the roots. So you have the values, you can crack them very easily. Well, alpha to the power 4 plus beta to the power 4. Now that's a little more challenging for us. Trust me, it is not challenging. See, If I write it as alpha square plus beta square whole square, well, when alpha square plus beta square is squared, I'll have alpha to the power 4 plus beta to the power 4. But I'll have something additional, 2ab sort of something. Well, that will be plus 2 alpha square plus beta, 2 alpha square beta square. That can be nullified or balanced with this minus 2 alpha square beta square. Well, you know everything now, because alpha square plus beta square can be brought from here into picture. And alpha square beta square is nothing but what? Alpha beta whole square, which is product of the roots, which you already know. So again, you know these values, and based on them, you can conclude this part. I hope you are understanding. They need not be derived or made you understand. They are very simple, basic algebraic identities which you have been studying since 8th standard. So I hope you are understanding how are they getting derived. Let's talk about alpha to the power 4 minus beta to the power 4. Again, a very simple result. Alpha to the power 4 minus beta to the power 4. Can it not be written as alpha square whole square minus beta square whole square, which will be a square minus b square, like kind of an identity, which will be a plus b and a minus b. So there is a small correction here. First of all, I'll be writing it as alpha square plus beta square, and then I'll be writing it as alpha square minus beta square. I hope you are able to understand this part. How did I get it? Because in this particular part, a and b are alpha square and beta square. So first of all, I'll have a plus b and then a minus b, because this is a square minus b square. I hope you are able to relate it with that. Now, what is alpha square plus beta square? We have already cracked it. What is alpha square minus beta square? We have already cracked it. So this is how you keep deriving these results based on whatever is asked. So these are the results which I'll strongly emphasize that you remember. Similarly, how do you crack alpha to the power 5 plus beta to the power 5? That's a little trickier one. How do you crack this particular part? So I'll use forced factorization here. How do we do that? Please understand. Let's say I write alpha to the power 5 plus beta to the power 5 as alpha square plus beta square into alpha cube plus beta cube. But when I do that, I'm making some error. I'm doing, or I'm additionally writing some more extra redundant, terms. How to adjust it? First of all, of course, we know alpha square into alpha cube will be alpha to the power 5. Beta square into beta cube will be beta to the power 5. But two extra terms we are getting. What are those two extra terms, students? Those two extra terms are going to be alpha square into beta cube plus beta square into alpha cube, which can be nullified by this expression if you look at this particular part very clearly, because this is alpha square beta cube and beta square alpha cube if you look at this particular expression closely. But what is the advantage of this? Because we know alpha square plus beta square, we have already cracked it. Because we know alpha cube plus beta cube, because we have already cracked it. Because we know alpha into beta, we know product of the roots. Because we know alpha plus beta, sum of the roots. So if you have these values, you can crack alpha to the power 5 plus beta to the power 5. Not just that, in the same fashion, alpha to the power 5 minus beta to the power 5 can also be cracked. So I hope you will remember all these identities. Again, results I must say, but they are very crucial. You know how to derive them, you know how to prove them. Proof is not important, derivation is more important. Simple, basic algebraic identities, if you are aware of, they can be converted into the desired results which the question asks. And JEE asks you questions based on these results. I hope you'll remember them. And if you'll remember them, I'll actually demonstrate with an example asked by JEE Mains in 2014-24 based on the same concept which we have learnt, symmetric roots of a quadratic equation. How do we do that? See, we are told alpha and beta are the two roots of this quadratic. The moment we see the quadratic, can we not conclude its sum of the roots and product of the roots? Yes, we can, right? Then we are told, we are asked to write a quadratic which has the roots alpha to the power 4 plus beta to the power 4 and 1 by 10 times alpha to the power 6 plus beta to the power 6. Now, if someone is thinking, sir, I'll find alpha and beta separately, and then I'll find alpha to the power 4 and beta to the power separately, and then I'll find alpha to the power 6 and beta to the power separately, then I have my best wishes to you. Go ahead. You will end up spending at least 15 to 20 minutes or maybe more than that doing that. You need not do all of that. Please understand, whenever you are thinking that much straightforward, there you stuck. You need to use some more better methods. You need to use your intuition. If I know alpha plus beta and alpha beta, I may get to this part and this part very easily. How? Let's have a look at that particular part. What I have is x square plus 2 root x minus 1, right? That's the quadratic we are dealing with. So we are having the quadratic x square plus, I'm really sorry, we have the quadratic. What is the quadratic, students? X square plus 2 root x minus 1 is equal to 0. Let me just verify this particular part. Yes, x square plus 2 root x minus 1 is equal to 0. And we are told that it has two roots. What are those two roots, students? Those two roots are alpha and beta. Can you help me with some of the roots? Some of the roots are going to be, students, alpha plus beta. Now, what do you mean by some of the roots? Alpha plus beta minus b upon a, right? X square plus 2 root 2x minus 1. Yes, we are right. So, alpha plus beta will be minus b upon a. That's minus 2 root 2. Can you help me with the product of the roots, students? Well, product of the roots is going to be alpha beta. So, alpha beta will be c upon a, which is minus 1 upon 1, which is minus 1. I hope this part is very well understood by all of you. Now, what I need to find is, let's say I need to find a quadratic which has two roots, a and b. Well, what is a in that case? Let's say a is alpha to the power 4 plus beta to the power 4. And what is b in that case? B is, let's say, alpha to the power 6 plus beta to the power 6. So we are trying to find a and b. What is a? Alpha to the power 4 plus beta to the power 4. So let's start working on alpha to the power 4 plus, sorry, what we are trying to find out is alpha to the power 4 plus beta to the power 4. Do I have a result for this? Yes, we have already cracked it. That alpha to the power 4 plus beta to the power 4 should be nothing but alpha square plus beta square whole square minus 2 alpha square beta square. I hope you remember this result. We have already discussed it. We have already evaluated it just before this particular slide, before this question only. Now, how do I deal with alpha square plus beta square? We know how to use that, right? Alpha square plus beta square can be dealt by a very simple expression. What is that expression, students? Alpha square plus beta square, can it not be written as alpha plus beta whole square minus 2 alpha beta? See, alpha square plus beta square plus 2 alpha beta minus 2 alpha beta. Do you not think I'll be left with this part? I hope you're realizing this particular portion. Minus 2 times alpha beta whole square. So this is what? Nothing but alpha to the power 4 plus beta to the power 4. But now with this result, we know alpha plus beta, we know alpha beta, we know alpha beta. We can crack alpha to the power 4 plus beta to the power 4. Are you realizing first root can be found very easily? Now, how do I proceed further? The result is very simple, students. It will be alpha plus beta whole square. What is alpha plus beta? Minus 2 root 2. So I need to have the square of minus 2 root 2. Then minus 2 alpha beta is minus 1, should be plus 2. Minus 2 alpha beta square. So square of minus 1 is 1, so it should be minus 2 only. Now, what is square of minus 2 root 2? So square of minus 2 root 2 is, I think, 8, because 2 square is 4, root 2 square is 2, 4 into 2 is 8. So 8 plus 2, this is 8, this is 2, 8 plus 2 is 10, 10 square is 100. And there we have 100 minus 2, which is 98. I think we have cracked the first root. I think we have cracked the first root, which is a, which happens to be 98. Now let's try and find out the next root, which is 1/10 of alpha to the power 6 plus beta to the power 6. Okay, so I'll try to do it here. I'm trying to find, first of all, alpha to the power 6 plus beta to the power 6, and then I'll do the 1/10 of it. So I'll do that 1/10 later, but first of all, I'm working on alpha to the power 6 plus beta to the power 6. Now, how do I do that? Alpha to the power 6 plus beta to the power 6. Can I not write that as, let's say for a while, alpha square plus beta square whole cube? Now I'm making some, again, I'm adding some more data to it. I'm adding some more values to it. I'm adding some more terms to it. Now, how do I get rid of them? Because when you say alpha square plus beta square cube, you're saying alpha to the power 6 plus beta to the power 6. But additionally, what you're saying is 3 alpha beta, I mean 3 alpha square beta square times alpha square plus beta square. So that may create some problem. So instead of this particular part, because this is getting a little lengthy, can I use a different result? Can I use it like alpha cube plus beta cube whole square? That looks a little simpler to me. I may have to do a little lesser calculation. That all depends. But we had to choose something. I'm choosing this particular part. Even the earlier part was also simpler, but that has its own calculation. So over that, I'm choosing this particular calculation. I hope no one is bothered by that. How do I proceed with this? Alpha cube plus beta cube square will be alpha to the power 6 plus beta to the power 6 plus 2 alpha cube beta cube. Now to adjust that, I need to have minus 2 alpha cube beta cube, which can be written like this. So I'm having lesser number of terms as of now, but I'll be having more terms here. But at least I'm having lesser number of terms. Now, proceeding further, how do I deal with this particular part? Alpha cube plus beta cube. We already know alpha cube plus beta cube can be written as alpha plus beta whole cube minus 3 alpha beta times alpha plus beta, right, students? This is what you know. This will be alpha cube plus beta cube plus 3 alpha beta into alpha plus beta. That gets nullified by this. So this is nothing but alpha cube plus beta cube, right? And this is needed to be squared minus 2 times alpha beta whole cube is needed to be done. That's brilliant. Now, proceeding further, I'll be writing the values here. Alpha plus beta, which is minus 2 root 2. So I'll be having cube of minus 2 root 2. Mind you, students, it is cube now. Then minus 3 alpha beta. What is alpha beta? Alpha beta is minus 1. Minus 1 into minus 3 should be plus 3 into alpha plus beta. What is alpha plus beta? That is minus 2 root 2. So I'll be having minus 2 root 2 here. Let's write it like this. And it is needed to be squared. Okay, that's fine. Then you have minus 2. Alpha beta is minus 1. Cube is also minus 1. Minus 1 minus 2 should be plus 2. This is the value we are getting, which when simplified gives you even better result. Please pay attention to this. Minus 2 root 2 cube. So 2 cube is 8, although it is minus 2. So minus 2 cube should be minus 8. I hope you're getting it. Minus 8 into root 2 cube. Root 2 cube is, I think, 2 root 2. I repeat this part very clearly. I'll write it separately so that nothing gets confusing. Minus 2 cube is, I think, minus 8. I hope this part is very well understood by you all. Then I need to take the cube of root 2. So cube of root 2 is 2 root 2. I hope you are getting this part very clearly. So it should be 2 root 2. I hope no one is confused by that. Then you have plus 3 into 2 root 2. I think that is minus 6 root 2. No confusion on that, I believe. And this is needed to be squared. And then 2 is needed to be added. Okay, so this particular part is what we are now dealing with. Now, I think that part is very simple because minus 8 into 2, I hope I'm taking care of these brackets very well. Yes, so minus 8 into 2 should be minus 16. Minus 16 minus 6 is minus 22. So this should be minus 22 root 2. Okay, so I'm writing this part here. Minus 22 root 2 needs to be squared, I believe, right? Yes, plus 2, right? And that is the value of alpha to the power 6 plus beta to the power 6. But I am finding b, which is this divided by 10. So this is needed to be divided by 10. We know 22 square is 484. So 484 into 2 is needed to be done. Okay, so I'll write it separately. 484 into 2, which should be 8. 8 doubled gives you 16, carry 1, 2 into 4, 8, 8 plus 1 is 9. So this should be 968. I hope this part is very well understood. 968 plus 2 is 970. And 970 when divided by 10 gives you 97. So the other root will be 97. So I think we have found the roots. And if you have found the roots, can you not write the quadratic, students? We know to write a quadratic, all we need is x square minus sum of the roots times x plus product of the roots is equal to 0. So I hope from here the question can be done by yourself, because we know roots 98 and 97. Sum of the roots will be 98 plus 97. Product of the roots will be 98 into 97, and there you can mark the correct answer. So this question can be solved further by yourself. My part was to make you understand how can you crack alpha to the power 4 plus beta to the power 4 and alpha to the power 6 plus beta to the power 6. And are you realizing how important these results are? I am constantly emphasizing, at least remember these 6 results, the initial 6 results. They are sufficient. Because of these 6 results, you can derive further results. And calculation was there in this question. So calculation was the part which might have bothered you. But yes, you have to deal with these things. This comes with this part where you deal with questions of IIT JEE, that if the concept is simple, they may try to bother you with the calculation, or sometimes concept and calculation both are there and you need to apply both. So I think this was that category of questions. Let's now talk about another very crucial concept, which is said to be the Newton's formula. Now, what is Newton's formula, students? Newton's formula is a very simple concept. It is a very interesting concept, very widely used by JEE mains and advanced both in a lot of questions. Every year in every shift, they asked at least one questions based on it. Questions more than one can also be asked, but minimum one question is definitely asked. This is definitely asked. So this is a short concept on which question will be asked. Now, what is the Newton's formula? Please understand, let's say I'm given a quadratic. I'm given a quadratic which is ax square plus bx plus c. So this is the quadratic we are now dealing with. The quadratic ax square plus bx plus c, right? Now, in this quadratic, we know that the roots are, let's say, alpha and beta. So I'm told that the roots are alpha and beta. So if I'm told the roots are alpha and beta, can I say alpha will satisfy it, which means alpha x square plus b alpha plus c will be 0. Similarly, beta will also satisfy it. Now let's say if I multiply this particular, I'm really sorry, what have I done here? I'm really sorry. This should have been a and alpha actually confuses. So I'll write it as a alpha square, right? So a alpha square plus b alpha plus c, I'm really sorry, should be equal to 0. If I multiply both these sides by alpha to the power n, since it is an identity, I can multiply. So I'm multiplying. Even for an equation, I can do that. So I'll multiply it by alpha to the power n. So alpha to the power n is going to be multiplied on both these sides. So a alpha to the power n plus 2 plus b alpha to the power n plus 1 plus c alpha to the power n is equal to 0. In the same fashion, can I not draw a result based on beta? Because beta must also satisfy it. Then I'll multiply both the sides by beta to the power n. So another result which I'll get is a beta to the power n plus 2 plus b beta to the power n plus 1 plus c beta to the power n is equal to 0. Now, if I subtract this part from this part, or if I add this part with this part, now based on what is asked, either I'll be asked to deal with alpha to the power n plus beta to the power n, or I may be asked to deal with alpha to the power n minus beta to the power n. So depending, if I'm asked alpha to the power n plus beta to the power n, I'll add both of these. If I'm asked to subtract alpha to the power n from, beta to the power n from alpha to the power n, I'll subtract this from this. Although this is not what you all are supposed to do, this is what I'm doing to make you understand that how are we getting this particular result. So I am given that there is an expression Sn, which is given by alpha to the power n plus beta to the power n. There is an expression which is given by either alpha to the power n plus beta to the power n or alpha to the power n minus beta to the power n. Now, my conclusion remains very simple, students, that if I subtract this equation from this equation, I'll have a times alpha to the power n plus 2 minus beta to the power n plus 2. So, alpha to the power n plus 2 minus beta to the power n plus 2, or if I'm adding these equations, then I'll have alpha to the power n plus 2 plus beta to the power n plus 2. Can I not say for a while, let's say minus sign was not given to me, plus sign was given to me. So alpha to the power n plus beta to the power n is Sn. And if I'm adding these two equations, if I add these two equations, I'll have alpha to the power n plus 2 plus beta to the power n plus 2. So can I not say alpha to the power n plus 2 plus beta to the power n plus 2 will be Sn plus 2? So can I not write it as Sn plus 2 plus b will be common from here. I'll be having alpha to the power n plus 1 plus beta to the power n plus 1. So alpha to the power n plus 1 plus beta to the power n plus 1 will be Sn plus 1. I hope this need not be explained further. So this should be b times Sn plus 1. Similarly, here c will be common. Alpha to the power n plus beta to the power n. We already know alpha to the power n plus beta to the power n is nothing but Sn. So this will be Sn is equal to 0. I hope you are able to understand. The fact remains very simple that if you are given Sn as either alpha to the power n plus beta to the power n or alpha to the power n minus beta to the power n, you directly look at the quadratic. Don't do all this. This is not what you're supposed to do. This is what I have tried making you understand, that why can we directly write this result, that if you are given ax square plus bx plus c and Sn is given as either alpha to the power n plus beta to the power n or alpha to the power n minus beta to the power n, I'll write another result, another conclusion, which will be A times Sn plus 1, B times Sn, and C times Sn minus 1. Well, it all depends. If I take Sn plus 2 here, I would have taken Sn plus 1 here, and I would have taken Sn here. So it all depends. If I am taking Sn here, it will be Sn minus 1 and it will be Sn minus 2. So Sn will keep on decreasing, but what you need to understand is this A, B and C remains as it is. So that's the Newton's formula. So Newton's formula is not something which you study in physics only. It is what you study in quadratic equations mathematics as well. A very crucial result, a very interesting formula, and it will help you a lot of questions with just one flick. How? Let's look at that part with one question over here. JEE Mains in 2022 has asked this question. What all are we given? Let's understand all of that in detail one after another. Alpha and beta are the two roots where alpha is greater than beta. That is what I am told. Roots of the quadratic equation x square minus x minus 4 is equal to 0. Okay. Now, I am defined a new term Pn alpha to the power n minus beta to the power n. The moment you see either alpha to the power n plus beta to the power n or alpha to the power n minus beta to the power n, what you should get in your mind is Newton's formula. That is something you should have in your mind. Now, n is a natural number. That's the best part. Then I'm asked the value of a certain expression. Now, how do I find the solution to this particular part? Let's start solving or simplifying this particular question through our own methods. I am looking at this like this, that can I take P16 common here? I hope we can take P16 common here. So if I'm taking P16 common from here, from this expression, I'll be left with P15 and P14. So I am taking P16 common here. Although, by the way, I have already started solving this question. And if you have understood the Newton's formula, and if you're able to see a certain pattern over here in this question, you can also start solving it simultaneously along with me. You can let this video, plays continuously, or if you want to pause it, you pause it, but solve along with me or even before me. I'll be really happy and proud if you are able to do it before me. Trust me. Now, P16 if I'm taking common from here, I'm really sorry, here and here, I'll be left with P15 and P14. So this P15 and P14 is what I am left with. Now, similarly, I can take P15 common from here. Rather, to have something like this, I'll take minus P15 common. So I am taking minus P15 common from these two terms. I'll be left with P15 minus P14. All right, that's brilliant. Now, what do I have next? The next we have is the denominator, which is P13 times P14. Sir, why are we doing all this? Trust me, spend some more time with this question. You will start seeing the results. What is that result? P15 minus P14, P15 minus 14, one factor. Other factor will be P16 minus P15. So one of the factors will be P16 minus P15, and the other factor will be P15 minus P14, right? Divided by P13 into P14, right? Now what? Have a look at this part. We are told that Pn is alpha to the power n minus beta to the power n. Now, can someone help me with this part, that how can I apply Newton's formula on this quadratic? Please understand, what was the quadratic, students? The quadratic was x square minus x minus 4 is equal to 0. This was the quadratic given to us. How can I apply quadratic or the Newton's formula here in this quadratic? Can I not say, sir, x square was given there? So Sn minus 1, Sn minus 2. That will be the order. Whatever degree or whatever value of n you take, minus 1 will come with these and these terms. Coefficients will remain same. So x square has a coefficient 1. Keep 1 as it is, but here you replace it by, let's say, Pn. So I'll be writing it as Pn minus, because the next term has the coefficient minus 1. Now, here I used Pn, so it should be Pn minus 1. I hope you are able to crack it. So here it should be minus Pn minus 1. Then I have minus 4, which will remain as it is, but the next thing will be Pn minus 2, right? So it should be Pn minus 2 is equal to 0. Tell me honestly, were you able to get this? How did I create the Newton's formula, students? If you didn't get it, look at this part again. What all I have done is a very simple part, that x square minus x minus 4. This is exactly what I've written. X square minus x minus 4. But instead of x square, I have replaced that by Pn, or Pn plus 2 if you want to call it. But let's say Pn for a while to avoid the confusion. So minus x I have written as minus Pn minus 1. And minus 4 into 1 I have written as minus 4 Pn minus 2. So just look at this particular quadratic and look at this Pn, which is either alpha to the power n plus beta to the power n, or alpha to the power n minus beta to the power n. Just write it like this. Are you understanding the method, the SOP, the modus operandi I'm asking you to apply? And if you have cracked it, that this is how things happen. If you are still getting confused, I'm again helping you with ax square asn plus 1, bx bsn, c csn minus 1. That's exactly what I'm doing. If I'm using Sn plus 1 here, Sn will be here, Sn minus 1 here. So to avoid confusion, what I have done is, if there was x square, Pn. If there was x, Pn minus 1. If there was 1, Pn minus 2. That's it. Coefficient remained as it is. 1 was here, minus 1 was here, minus 4 was here. So that's how I have written the Newton's formula. Are you comfortable with this? Can I proceed further now? If you have understood this particular part, let us move ahead with the next part, where I say that now it's the time that we use this particular result. Or if I rewrite it as, then can I not say Pn? I'm really sorry. Can I not say that the result will be Pn minus Pn minus 1 will be 4 times Pn minus 2? Question is done if you have started looking at the solution. Please understand, if I replace n by 16 here, P16 minus P15, I hope you are seeing P16 minus P15 is 4P13. I hope you are seeing, if I replace n by 16 here, P16 minus P15 is P4P13. So this P16 minus P15 can be replaced by 4P13, right? Similarly, I am seeing a 15 here. So if I replace n by 15 here, I'll be having P15 minus P14. P15 minus P14 is equal to 4P13. So that is going to be another term, 4P. I'm really sorry. I think I have made an error. I repeat, P16, P15 should not be 4P13. P16 minus P15 would be 4P14. I repeat my part. 16, 15, 14. So this should have been 14. I'm really sorry for that. So here it should be P14. I'm really sorry. I mistakenly wrote it as P13. Next part. P15, P14 will be 4P13. So it should be 4P13. What is the next part, students? The next part is even simpler, even easier. That is going to be P13 into P14, which is going to be here P13 into P14, which will help you getting the final result very easily, because P14, P14 are nullified, P13 and P13 are nullified. You're left with 4 into 4, which is nothing but 16. This is how easy these questions are if you know the Newton's formula. Once you get the DPPs, the practice sheets, once you get the previous year's questions, you will see a lot of questions every year being asked based on this concept. I have just tried to give you the idea how to use it, how to apply it, and how can you fetch or get the answer by seeing the pattern. So this is something which needs to be managed or arranged. First of all, there is some intuition needs to be applied here. Well, that intuition can be cracked with the help of the quadratic given to you, somewhat like this. And after that, whatever expression in terms of Pn or Sn you are able to get, make or generate, that needs to be applied on the expression whose value we are asked. Although some simplification of that expression may also be needed to be done, but that I think is doable. So I think it is a very simple, very easy, very interesting question. You all have gotten the clarity and the idea how to approach this category of questions, right, students? Now we'll talk about transformation of quadratic equations, that how do you transform them. For example, let's say we are given a quadratic ax square plus bx plus c is equal to 0, and it has roots alpha and beta. And what are we asked? We are asked another quadratic which can have roots alpha plus k, beta plus k, or alpha upon k, beta upon k, something like that. So is there any method through which we can directly generate the results? Yes, there is. One of the methods could be you find alpha and beta, and then you find alpha upon k and beta upon k, and then you write the quadratic, which is of course going to be a little cumbersome process. So here we are going to discuss one of those methods which is very simple, straightforward, and will give you the direct results very efficiently and effectively. Questions are asked. We'll see some illustrations and examples as well, through which you'll understand it more clearly. But first of all, let us understand the logic, that how is it done. Then we'll understand the short technique, that directly how can you do it. And then with examples, we'll consolidate it. So let's look at this logic first of all. Let's say we are given a quadratic ax square plus bx plus c is equal to 0, right? And it has two roots, alpha and beta. Well, that's perfect. Now, let's say I am asked to write a different quadratic which has roots, let's say alpha plus k and beta plus k. Now, can we see some symmetry here? Yes, alpha plus k, beta plus k. So they are symmetric roots, right? Because alpha and beta can be interchanged and the roots will still remain intact. I hope you are understanding this particular logic. Now, let's say there could be a quadratic which has the roots alpha plus k comma beta plus k. Okay, that's fine. So let's say that quadratic is capital AT square plus capital BT plus C is equal to 0. So that is the quadratic which has the roots alpha plus k and beta plus k. Here we have written the quadratic in terms of t. The variable is t here. Could be x, it could be anything else, but let's say the variable I have taken is t. I hope this part is very well understood. Now, can you help me with this part, that if t is the quadratic's variable, then shall I say t will take the values alpha plus k and beta plus k? I hope you're getting my language very clearly. So if t can be replaced by alpha plus k or beta plus k, this equation will get satisfied. What does it mean? That from here, can I deduce what will be the value of alpha? I hope we can. That alpha is going to be nothing but what? Alpha is going to be t minus k. Alpha is going to be t minus k. Now that's a very crucial result. Why? Because this equation has a root alpha. So this equation will get satisfied by alpha. Now what does it mean? This equation can be satisfied by alpha, which means a alpha square plus b alpha plus c is equal to 0. Now what do we know? The value of alpha is t minus k. The value of alpha is t minus k. So if the value of alpha, which is t minus k, if replaced here, it will be t minus k whole square plus b times t minus k plus c is equal to 0. Can you see something happening over here? Can you notice something very interesting here? Can someone help me that what am I trying to suggest here? Well, the idea is very simple, students. The idea is very straightforward. What I'm trying to make you understand is that if I expand this particular part, I'll get a quadratic in t. I repeat, if I expand this particular part, I'll get a quadratic in t. Well, that quadratic in t will have the roots alpha plus k and beta plus k. Because we have already discussed, if you have a quadratic in t, that will have the roots alpha plus k comma beta plus k. Are you getting my point very clearly? All I have done is nothing, but I have simply substituted x by t minus k. Can you not see it happening over here? I have simply substituted x by t minus k over here if you pay attention to this particular path. I hope you are understanding the logic. You need not even substitute x by t minus k. Let's say in a very simple language, I am given a quadratic ax square plus bx plus c, जिसके roots हैं alpha and beta. Let's say it has the roots alpha and beta. Now what am I asked? Let's say I'm asked another quadratic which has the roots alpha plus k and beta plus k. Now how do I deal with that? The logic is very simple, students. All you need to do is replace, first of all, take x as alpha plus k, right? From here, you will be able to find the value of alpha as x minus k. Do nothing, but the x which you are finding here, the x you have found here, replace that x by x minus k. That's the modus operandi or the standard operating procedure will follow. I'll repeat this particular part with some more examples. All I'm trying to make you understand is a very simple process. Let's say if I'm given a quadratic ax square plus bx plus c is equal to 0, which has the roots alpha and beta, right? I am asked another quadratic which has the roots alpha plus k and beta plus k. Do nothing but replace x by x minus k and your job will be done. Just replace x by x minus k and you will get a different quadratic which will have the roots alpha plus k and beta plus k. I'll try and explain it with one more example. You'll get more clarity. Let's say again we have this quadratic ax square plus bx plus c is equal to 0 and it has the roots alpha and beta, right? It has the roots alpha and beta. And I am asking you to write another quadratic which has the roots alpha k and beta k, which has the roots alpha k and beta k. So first of all, write x as alpha k. Now from here, find the value of alpha. So alpha will be x upon k. Alpha will be x upon k. And from here, do nothing but simply substitute this x by k. Because this quadratic in x is getting satisfied by this alpha, right students? And if alpha satisfies this quadratic, alpha has a value x upon k, so that x upon k can be substituted here in place of x. And then you'll get a quadratic in x which will have the roots alpha k and beta k. Are you understanding the logic? Are you able to deduce the process? Let's have a look at the different parts where this particular logic is used. For example, if I'm asked to write a quadratic which has the roots alpha minus k and beta minus k, right? Now what will you do? You'll write x is equal to alpha minus k. What will you get? You'll get alpha is equal to x plus k. So all you need to do is substitute x by x plus k. That's it. The new quadratic formed will have the roots alpha minus k and beta minus k. Are you able to get this particular part? This part, I hope we have already discussed. If I need a quadratic alpha k with the roots alpha k and beta k, what am I supposed to do? I hope you are able to understand. I'll write x is equal to alpha k. Alpha will be x upon k. So I'll substitute x by x upon k. That's it. That's how simple it is. For example, if I'm asking you to write a quadratic which has the roots alpha upon k and beta upon k, what are you supposed to do? X is equal to alpha upon k. So alpha is kx. So all I need to do is substitute x by kx. I hope you are able to develop the logic. Similarly, let's say if I'm asked to write a quadratic which has the roots minus alpha and minus beta. See how simple it is. I hope you are able to understand this logic. Let's say I need to write a quadratic which has the roots minus alpha and minus beta. What am I supposed to do? I'm supposed to write x is equal to minus alpha. So alpha becomes minus x. So what am I supposed to do? I'm supposed to substitute x by minus x. So whatever quadratic I'm given ax square plus bx plus c, in that quadratic in place of x, what are you supposed to do? Substitute minus x in place of x and you'll get a quadratic which will have the roots minus alpha and minus beta. Are you able to understand this? Well, this all can be done when the roots are symmetrical. See, the roots are minus alpha minus beta, alpha upon k, beta upon k, alpha k, beta k, alpha plus k, beta plus k. So there should be symmetry. Then only this particular logic can be applied. I hope you are understanding and remembering the constraint here. Well, let's understand it in a more clearer manner with some more different transformations you are supposed to learn. For example, let's say I'm asked to write a quadratic which has the roots 1 upon alpha and 1 upon beta. Can you reduce the logic? I hope most of you must have cracked it that, sir, x should be 1 upon alpha, which means alpha should be 1 upon x. So all you need to do is replace x by 1 upon x. That's exactly what I'm suggesting you to do. Are you realizing how simple this is? You have understood the logic, you know the short technique, apply this and get the answers within seconds. That's what I'm saying you. Now, similarly, let's say if I'm asked to write a quadratic which has the roots minus 1 upon alpha minus upon beta. I hope this is very simple. Now, can we do it verbally? Minus 1 upon alpha is equal to x. So, alpha will be minus 1 upon x. That's it. That's the substitution you're supposed to make. So x should be substituted by minus 1 upon x. Are you able to develop this logic, students? Similarly, let's say I'm supposed to write a quadratic which has the roots k upon alpha and k upon beta. So k upon alpha is equal to x. So x alpha will be k upon x. So all you need to do is substitute x by k upon x. Are you able to get this logic, students? Let's proceed further. This is more interesting. Let's say p alpha plus q, right? Let's say I need to write a quadratic which has the roots p alpha plus q and p beta plus q. Again, there is symmetry. That's the most interesting part here. So let's say I take p alpha plus q as x. Can I deduce the value of alpha from here? I hope we can very clearly say alpha will be x minus q upon p. So if alpha is x minus q upon p, you know what is needed to be substituted here? Well, x should be substituted by x minus q by p. That's the substitution. Well, that is something I am able to do only when the roots are symmetric in nature. P alpha plus q, p beta plus q. So the roots were completely, totally, absolutely symmetric. I hope you are understanding this particular logic. Well, similarly, if I am asked to write a quadratic which has the roots alpha to the power n plus beta to the alpha to the power n comma beta to the power n. So I hope the logic is very simple. Alpha to the power n is equal to x. So alpha will be x to the power 1 by n. So all you need to do is substitute x by x to the power 1 by n. That's how simple this is. Did you get this particular part? I'm sure you must have understood with these many different cases or scenarios. And if you have gotten the logic, can we discuss a question, a very amazing question asked by JEE Advanced way back, but a very interesting question which will give you a lot of clarity. Always remember, students, there are two categories of questions which you will face in your life. Simpler and easy ones, tougher but bad ones. Bad means they will make you feel bad. You will struggle while doing them. You will actually have to put a lot of efforts while solving those questions. So those questions may not make you feel good, but those questions will actually do good to you. So there is a difference between doing those questions which make you feel good, doing the other set of questions which actually are good for you, but they don't make you feel good. So I hope you are remembering or learning the difference. So always put your efforts on solving this good category of questions which actually do good to you. They may not make you feel good, but they'll do some really relevant good to you regarding or relevant to this particular examination. Well, let's focus on this particular part where I'm saying that the question is very simple. What is it? It says alpha and beta are the roots of this particular quadratic, and then we are asked the value of this particular expression. One of the values could be find alpha and beta by solving the quadratic and then put those values here and get the answer. Well, that's perfectly doable if the roots are very simple. If the roots are very simple natural numbers or some rational numbers, I could have done that. But to me, it looks like this quadratic may have some irrational numbers, because if you look at the discriminant, it is b square minus 4ac. So 2 square is 4. I hope you can see it very clearly. If I try and write the discriminant of this quadratic, it will be this particular expression. I repeat this particular part. The discriminant will be b square, which means 2 square minus 4ac. So 4 into 3 is 12. Well, the problem has arisen here that this particular discriminant is even negative. So the roots are going to be complex. The roots are going to be imaginary. And when you're dealing with complex roots, putting alpha and beta, I hope you're realizing how greatly, enormous problem this will become if you're solving it with finding the root. So that is not something which is advised to you all. So what can be done in that case? That's what we'll be discussing here. The approach will remain very simple, students. Let's say, I hope one thing which you all must have noticed it, that 1 minus alpha, 1 plus alpha, 1 minus beta, 1 plus beta. Can you see some symmetry? 1 minus alpha, 1 minus beta, 1 plus alpha, 1 plus beta. So there is symmetry. Alpha and beta, if are interchanged, the roots will remain same. The expression will remain same. What I'm trying to make you understand is, let's say there exists a quadratic. Let's say there exists a quadratic which has two roots, a and b, capital A and capital B, where capital A I'm taking as 1 minus alpha upon 1 plus alpha, and capital B I'm taking as 1 minus beta upon 1 plus beta. So in a simpler language, I need to find the value of a cube plus b cube. So this, let's say, is the question. I hope this particular part is very well understood by you all. Now, how do I proceed further? Please understand, the logic is even simpler. How do I do that? Let's talk about this particular equation. This equation has the roots alpha and beta, right? This equation has the roots alpha and beta. Can I write a quadratic which has the roots 1 minus alpha upon 1 plus alpha and 1 minus beta upon 1 plus beta? Transformation of quadratic equations we have discussed. Can we use that particular logic? Let's try to think like that. See, let's say there will be a quadratic which has the root which is the quadratic in the variable t, let's say, for a while, and which has the root 1 minus alpha upon 1 plus alpha. Now you have two choices here. Either you apply component and dividendo and then you write alpha in terms of t, or you simply do this cross multiplication thing and get the value of alpha in terms of t. So 1 plus alpha goes to the other side, so it should be t plus t alpha, and here you're left with 1 minus alpha, right? What I do next is I fetch this alpha on the here and t on the other side. So there should be t alpha plus alpha, which is alpha times 1 plus t, and here it is 1 minus t. So from here, the value of alpha is found to be 1 plus t upon 1 minus t. This is exactly what you're taught while solving questions based on transformation of quadratic equations, right? What are you taught? That now this alpha should be replaced by 1 plus t upon 1 minus t. Alpha is the root of this particular quadratic. So alpha can be substituted here. But rather than replacing alpha, can I replace alpha or x by 1 plus t upon 1 minus t? Well, by that, I'll get a quadratic in t. Which will have the roots capital A and capital B. Because what is t? T is 1 minus alpha upon 1 plus alpha, or 1 minus beta upon 1 plus beta. Are you getting this logic very clearly? So I'll replace this particular expression. I'll have this x get replaced by alpha. Rather, alpha is 1 plus t upon 1 minus t. So I'll replace x by 1 plus t upon 1 minus t, and I'll get a quadratic in t. I hope you're understanding the approach. And that quadratic in t will have the roots capital A and capital B. So I hope you're getting this logic. How are we solving this particular question? So now I'm going to write the quadratic, with the help of this particular quadratic. So x I'm replacing by 1 plus t upon 1 minus t. I hope you're getting this logic. Why? Now, 3x square plus 2x plus 1, that was the quadratic. 3x square plus 2x plus 1 is equal to 0, right? But here I know that x can be substituted. X means alpha can be substituted or replaced by 1 plus t upon 1 minus t. So I'll replace 1 plus t upon 1 minus t here. So 3 times 1 plus t upon 1 minus t whole square plus 2 times 1 plus t upon 1 minus t plus 1 is equal to 0. What I'm going to do here is that I'll multiply both these sides by 1 minus t whole square. I hope you are understanding why. Because I'm basically taking the LCM here, but through a different mindset. So 1 minus t whole square when multiplied on both these sides, I'll be left with 3 times 1 plus t whole square. Here, I'll be left with 2 times 1 plus t. See, I have multiplied it by 1 plus t, 1 minus t whole square. I hope you can see it. So 1 minus t whole square when comes gets cancelled by this particular 1 factor, and 1 factor still remains intact, 1 minus t. And here, when 1 minus t square is multiplied, it is 1 minus t whole square is equal to 0. So I have gotten an expression 3 times 1 plus t whole square, 2 times 1 plus t into 1 minus t, because 1 minus t is getting cancelled here, and this 1 into 1 minus t whole square will remain 1 minus t whole square is equal to 0. I'll try and simplify it further, then I'll get a different result. What will be that result? 3 times t square, then 3, then 2t into 3, which is 6t. Here I'll get 1 minus t square into 2, that is 2 minus 2t square. Here I'll have 1 plus t square minus 2t is equal to 0. Let me just cross check it. 3t square plus 3 plus 6t. 2 minus 2t square, that's great. 1 plus t square minus 2t. Yes, we are going great. So let's proceed further with simplification of this particular equation. So 3t square minus 2t square is t square plus t square is 2t square. So I have gotten a 2t square here. Then 6t minus 2t, that is nothing but 4t. That's brilliant. Then 3 plus 2 is 5 plus 1 is 6. So that's your 6 here. Now, if I take 2 common from here, I'll get another simplified version of it, which should be t square plus 2t plus 3 is equal to 0. Are you all comfortable with whatever I've written so far? Everyone with me, students? All I have done is I have gotten a quadratic in T. And if it is a quadratic in T, it should have roots capital A and capital B. It should have roots capital A and capital B. So this quadratic will have the roots capital A and capital B, right? I am not asked the value of capital A and capital B. Then what am I asked? We are asked the value of a cube plus b cube. Okay, we'll find a cube plus b cube, but before finding a cube plus b cube, can I write a plus b? Sum of the roots, minus 2. I hope I need not explain this part. Product of the roots, I hope you know, 3 upon 1, that's 3. So now, if you are asked a cube plus b cube, do you not have the answer, students? If you are asked the value of a cube plus b cube, this is what we have already discussed while understanding identities. Do you remember that? Now, if I am asked a cube plus b cube, we already know it can be written as a plus b whole cube minus 3ab times a plus b. Now, I'll leave the remaining job up to you, that you need to do it by yourself, because you have the value a plus b, you have the value ab. All you need to do is take those values a plus b and ab here, from here, and put them here. By putting those values, in the next step, you will get the values of a cube plus b cube, and the job will be done. Why? Because a cube plus b cube is this cube plus this cube, which is exactly what we are asked. Question was simple, it was doable, it was straightforward if you know the concept. Transformation of quadratic expressions or equations. I hope you're understanding it very clearly. And if you have understood this particular part, let's move to the next part where we discuss roots under special cases. That what are the conclusions which can be drawn when you know few things regarding roots. For example, let's say I say that you have two roots, alpha and beta, but I say that both of the roots are negative. Then what will you say? You will say, sir, if both of the roots are negative, then my logic says that the sum of the roots should be negative, but the product of the roots should be positive. But sir, if the two roots really exist, then for their existence, the discriminant should be greater than or equal to 0. So such conclusions, that what all can be deduced, if something related to roots is given, then what conclusions can be drawn? Those conclusions will be discussing when roots are kept under different special cases. Another very crucial concept, because in JEE mains you will see a lot of questions where roots are not given, but something related to roots, their sign or something like that is given, and then on the basis of this, something related to the quadratic is asked, and all of this is done when some inequalities are created, and then you solve some inequalities and then you find the answers. Although we'll be seeing some illustrations from the past year's questions, of course, but as of now, let us understand what all needs to be understood, that what are the different cases and what conclusions must be drawn after reading those cases. I hope this part is understood. What I'm trying to make you understand here is, let's say there is a quadratic ax square plus bx plus c is equal to 0. So always remember, I'll keep mentioning this as the quadratic ax square plus bx plus c. I'll take the two roots as alpha and beta if it has two roots, where I'm clearly saying that alpha a is not equal to 0, which means this is a quadratic, and a, b, c are real. So as of now, I have constantly been talking about the real quadratic equation. All right. So it can have two roots, it may not have. Whatever is the case, we'll discuss that one by one. I hope what are we going to do is very well understood by you all. Let's take the first case. What does the first case say? If the roots of equation 1 is the quadratic basically, are equal in magnitude, but opposite in sign. Are you getting this? Let's say one of the roots is 2, the other root should be minus 2. Did you get my part? If alpha is 2, beta is minus 2, alpha plus beta will be 0. That's it. That's it. So if the two roots are equal in magnitude but opposite in sign, then sum of the roots, alpha plus beta will be 0. I hope you know this. Why? And if the two roots exist, if the two roots are there, because the sum of those two roots is 0, then they should be distinct, because if one of them was 2, other was minus 2, so they should be distinct and real, which means for that d should be greater than 0. So two conditions I need to apply. First, sum of the roots minus b upon a should be 0. If minus b upon a is 0, b should be 0. That is the conclusion. And second, for the existence of real and distinct roots, discriminant should be positive. So these two conditions are always necessary and sufficient if someone is saying that the roots are equal in magnitude, opposite in sign. That's it. I hope you are able to understand what I'm trying to convey here. Next case. Next case says roots are reciprocal to each other. Roots are reciprocal to each other. If roots are reciprocal to each other means if one of the roots is 2, the other root is 1 by 2. Well, in that case, if the two roots are reciprocal to each other, you know the product of the roots will be 1. So the logic remains very simple. The product of the roots alpha into beta is 1, which is C upon A is 1, which means A should be C. So the conclusion should be, first of all, A should be C. Now, they are reciprocal to each other. They can be equal because reciprocal of 1 is 1. Reciprocal of minus 1 is minus 1. So roots can be either equal or distinct, but they should be real. So for the existence of real roots, I need to ensure that the D is greater than equal to 0. So whenever somebody says that the roots are reciprocal to each other, I need to apply two conditions. What are those two conditions? First condition, A and C should be equal. And the second condition, D should be greater than equal to 0. I repeat, you need not memorize it. You need not by heart this particular result. You need to understand this part, that whenever somebody says this particular kind of thing, this is what you need to think. So I am asking you what you need to think, what you need to think of. How should you come up with the approach or the mindset I'm asking you to develop, that in this scenario, this is needed to be done. In this scenario, that is needed to be done. So different scenarios I'm putting forward in front of you, and I'm asking you to apply these kind of logics. I hope you're understanding that the logics are very simple. Because you know a lot about quadratic equations now so far after watching this much part of this video. I hope you're realizing we are covering it in a complete detail format. All sorts of detail, all sorts of things are getting completed as far as quadratic equations are considered. Along with that, we are doing a lot of questions. So theory part we are already taking care of. Questions are also being done so that theory is consolidated with those previous year's questions, illustrations, and examples. Along with that, of course, you will get the practice sheet, the DPPs, through which you will consolidate it even better, which is exactly what we are focusing upon, that you should practice more at this stage. Not just that, you'll get test series, these handwritten notes, a lot more at absolutely free of cost. So utilize this opportunity. Everything is done for you. Please understand, this is something very interesting which is done for you at absolutely no cost. This kind of quality content is provided to you. Well, with that, if I proceed further with the next conclusion, what are we told? That the roots are of opposite sign. So let's say if the one root is 2, the other root is minus 3. Right. So if the roots are of opposite signs, what can I conclude? That the product of the roots will be negative, because the roots could be 2 or minus 3 or 3 or minus 2. So I cannot conclude anything related to the sum, because 3 minus 2 will be 1, but 2 minus 3 will be minus 1. So the sum of the roots could be negative or positive. Well, that cannot be concluded. So in that case, I'll say, sir, I can say something about product of the roots at least. What does that mean? That means if one alpha is negative, beta is positive, or vice versa, their product will be negative, right? And if their product is negative, which means C upon A will be negative. I hope you're realizing. So by that, you can apply a condition as per whatever is asked in the question. And of course, you have two real roots whose product is negative. So if there are two distinct real roots, which means the discriminant should be positive. So again, two conditions are to be applied. This you need not remember. Please understand, this is even more elaborated or simplified version of it, which I don't ask you to remember. But at least this is what you should learn. This is what you should understand. This is more crucial for you. This is something you should simply ignore. Nothing needs to be remembered like that. This is even more confusing for you at this stage. Now, again, the next conclusion is if both the roots are positive. Now, I have said, let's say the one of the roots is 2, other root is 3. How simple that is. Sir, if both the roots are positive, I'll say that their sum and product both will be positive. Well, that's it. If the sum is positive, which means minus b upon a will be positive. If the product is positive, which means c upon a will be positive. And of course, for their existence, their discriminant should be greater than or equal to 0. So that will be the third condition I'll apply. So three things I'll be applying if both of the roots are positive. A, sum of the roots should be positive. Product of the roots should be positive, and D should be greater than or equal to 0. I hope you are learning these conditions, which are given in a very detailed format here. Now, next case, if both roots are negative, I hope you have started developing the logic now, that how should you think, what should be the approach. I repeat, both are negative. Now both are negative means what? Alpha and beta both are negative. What does it mean? Their sum will be negative, their product will be positive, because two negative numbers when multiplied give you a positive number, but two negative numbers when added give you a negative number. But of course, for their existence, for them to be real, the discriminant should be greater than equal to 0. So three conditions: sum will be negative, product will be positive, but discriminant will be non-negative, that is greater than equal to 0. So if both roots are negative, then sum of the roots will be negative, first condition. Product of the roots will be positive, second condition. And third condition, discriminant should be greater than equal to 0. That is what we'll be doing in this particular part. Proceeding ahead, let's take an example, then we'll discuss some more conclusions, but this will give you all what we have been discussing and why are we discussing. The example is right there in front of you. A question based on this particular concept was asked by JEE Mains in 2025 only. Every year they ask you questions based on this particular concept as well. How do we do that? The set of all values of P which are real. So P is a real number, okay, for which both the roots of this equation are negative real numbers. So what do I know? That the two roots are given to this equation, although alpha and beta are reserved for something else. So let's say this equation has two roots, x1 and x2. What am I told? That both x1 and x2 are negative real numbers, You know the case, right? So if both the roots are negative, what do I know? If both the roots are negative, let's say x1 and x2, then their sum will be negative, first case. Second case, their product will be negative. If both of them are negative, their product will be positive. I'm really sorry for that. And I hope you're understanding why am I using the conjunction and, because this needs to be satisfied, and along with this should also be satisfied, and along with this, the third case, two roots must exist, right? So for that, D should be greater than equal to 0. So these are the three cases we should abide by, and we need to find the intersection of these three cases, mind you students. If you have gotten the answer, do write it in the comment box. I'm waiting for your answers. By the time I am also solving it, if you want, you can pause the video and do it by yourself, because you know the approach now. Let's do it together now. Let's say, first of all, x1 plus x2. What do you mean by x1 plus x2? Sum of the roots, which is minus b upon 2a. What is minus b? That is p plus 2 upon a, which is 1. So p plus 2 should be negative, which means p should be less than minus 2. That's your first conclusion. Second conclusion, product of the roots should be positive. What is the product of the roots? C upon a, which is 2p plus 9 upon 1. So we have another conclusion, 2p plus 9 upon 1 should be positive, which means p should be greater than minus 9 by 2. That's your second conclusion, mind you students. Now let's look at the third conclusion. What is that? That is discriminant, which is b square minus 4ac. What is b square? Minus p plus 2. This needs to be squared. So even if I square minus of p plus 2 or p plus 2, that will remain same, because negative when squared gives you a positive number. Minus 4ac. So minus 4a is 1, c is 2p plus 9. This should be greater than equal to 0, right students? What will be p plus 2 square? This should be p square plus 4p, because 2ab, and then you have this 4, then you have minus 8p from here, then you have, I'm really sorry, it should be 4 into 9, which is minus 36. So it should be minus 36 greater than equal to 0. With that, if I simplify this particular part, what do I get? I am left with p square here, then 4p minus 8p is minus 4p, then 4 minus 36 is minus 32, should be greater than equal to 0. Now, I'll apply a different method which is not being taught to you, but yes, you can learn it very easily. P square minus 4p minus 32, right? I'll solve it differently here. P square minus 4p minus 32, we are asked to keep it as positive, non-negative rather, है ना? Okay, that is what we need to do. So, I hope you can see I need to split minus 4p so that the sum is minus 4, product is minus 32. I think that was already splitted minus 8 and plus 4. That's exactly what we were given. Yes. So I'll use that logic only. P square minus 8p plus 4p minus 32 greater than equal to 0. So one of the factors here, students, will be, I'll take p common from here. So if I take p common from here, I'll be left with p minus 8. What did I do? I took p common, right? I need to make this also p minus 8. To make it p minus 8, I'll take plus 4 common. So here I'll be having p plus 4 greater than equal to 0. Now, the logic is very simple. I'll be using the Wavy curve method. What does it say? See, from here, I am getting the value of p as 8. From here, I'm getting the value of p as minus 4. You have plotted these two factors or roots here on the number scale. Now, this will be plus infinity, this will be minus infinity. All you need to do is put a plus sign here, a minus sign here, and a plus sign here. Plus, minus, plus from the right hand side. I have put plus, minus, plus here. What I need is, I want this expression to be greater than equal to 0. Now, what does it mean? Greater than equal to 0, which means it should be non-negative, which means it can be either 0 or positive. So it is positive between 8 and infinity and between minus infinity to minus 4. And when is it 0? It is 0 when p is either minus 4 or plus 8. So I'll be saying that it should be either equal to 8 or greater than 8, or it should be equal to minus 4 or less than minus 4. I hope you are understanding it. Because for all the values of x which are either less than equal to minus 4 or greater than equal to 8, then your expression is found to be positive. We'll talk more about this particular part, that how did we deduce it, how can you do it further with more clarity when we discuss the concept Wavy curve method, but a shorter version of it, I hope you are able to understand. So from here, I can say that p is between, minus infinity to minus 4 and 8 to infinity, where minus 4 and 8 are included. So here, I'll say that p lies between minus infinity to minus 4, or means union, mind you students, 8 to infinity, right? Now, what I need to do is, I need to solve here with a different part where I say that let's solve it here. I'll plot the number scale here, right? I'll be plotting the number scale here, right? So I'm plotting the number scale here. Let's say this is the number scale. Okay, I hope you are comfortable with this part. So this here is the number scale. Let's say I am fetching it a little downward. I hope you are getting it very clearly. So let's say this is minus infinity. This is plus infinity. What does this conclusion say? This says p should be less than minus 2. Okay, so let's say minus 2 lies here and it says p should be less than minus 2. That was your first conclusion. What was the second conclusion? Second conclusion, that p should be greater than minus 9 by 2. I think minus 9 by 2 is minus 4.5. So I am taking minus 9 by 2 here, and it is saying that p should be greater than minus 9 by 2, which means p should be greater than minus 9 by 2 will go somewhat like this. I hope that part is also very well understandable. Now, let's talk about the third case. P should be less than minus 4. So if this is minus 4.5, minus 4 will lie somewhere here. So if it says p should be less than minus 4, so it can go like this. But it can be greater than 8 as well. So I think 8 may lie somewhere here. So it says either it should be less than minus 4 or greater than 8, where minus 4 and 8 are included. Now can you help me in finding the intersection here? Intersection means all the three conditions should be satisfied. See, if I look very closely, I am seeing that this particular portion, minus 9 by 2 to 4, this is the region where I am seeing the portion where the intersection is happening. How? Let me give you more clarity. See, this is the portion where these two exist, but this doesn't. This is the portion where these two exist, but this doesn't. This is the portion where this and this don't exist, but this does. This is the portion where these two exist, but the third one doesn't. So I hope you're realizing I need a portion where all three of them should exist. Well, all three of them are existing here. First, second, and third. All three of them are existing between minus 9 by 2 and minus 4. I hope you are getting this logic very clearly. I repeat. So I'll say the condition or the value of p which gets satisfied so that this condition is fulfilled, where they are wanting it to be having two negative real numbers, the condition will be very simple, that P should lie between minus 9 by 2 to minus 4, where I am not supposed to include minus 9 by 2, but I am supposed to include 4, minus 4. I hope you are getting this logic. So our answer finally will say that P will lie between minus 9 by 2 and 4, where 4 is included and minus 9 by 2 is excluded. Did you get that part, students? Well, when you compare it with this result, you can compare and get the values of beta and alpha. By putting these values beta and alpha here, you can get and mark the correct answer. That can be done by you. The most important part, that how do you apply the inequalities, how do you take the intersection, how do you solve a quadratic inequality, that part was needed to be understood, and I hope that part is very well understood by all of you. Tell me how many of you got the correct answer, how many of you were able to get this interval minus 9 by 2 to 4, where 4 was included and minus 9 by 2 was excluded. Tell me. With that, let's get more clarity, let's understand it in a more detailed format. Some more cases are there, but these are simply the extension of the cases which we have already studied so far. For example, if I say at least one of the roots is positive. Now, what do you mean by at least one of the roots is positive? When somebody says at least one of the roots is positive, it simply means, students, it simply means at least one, which means either one is negative, one is positive, or both are positive. See, I am telling you that this case had one root positive, and this case over here, where here had both of the roots positive. So if I take the intersection, if I take the, union of first and fourth case, then can I not have at least one root to be positive? Please understand what is the meaning of the word at least one root to be positive. When I say at least one root is positive, what does it mean? It means either exactly one root is positive. I hope you are getting it. Or both of the roots are positive. I hope you are getting the language very clearly. So either one root is positive is happening with the first case when roots are of opposite in sign. So one is positive, one is negative. Or both are positive is happening in the fourth case when both of the roots are positive. So the logic remains very simple. Either one is negative, one is positive, or both are positive. So I need to take the union. I am not supposed to take the intersection. I am supposed to take the union. So I'll solve it with the first condition, then I'll solve it with the fourth condition, and I'll take the union. When I'm asked at least one root is positive, I hope you're understanding the meaning of the word when somebody says at least one root is positive. Similarly, let's say the second case arises. In the second case, it says if at least one of the roots is negative. Again, what does it mean? If at least one root is negative, then either exactly one root should be negative or both of the roots should be negative. So exactly one root is negative to be found in this first case when one is negative and one is, I'm really sorry. It's not first case. It is third case. I'm really sorry. I did not read it. So I repeat my part. I am correcting myself. I'm coming back to this part where I did not notice. I'm supposed to take the union of third and fourth. In this case, when at least one of the roots is positive. I repeat because I did not read it. The first case was the case when roots were equal in magnitude. No, that was not the case. We need to have, I hope most of you must have noticed it if you were watching it attentively, cautiously. You will say, if I want at least one root to be positive, although whatever is written on the slide is correct, I just took the wrong number from here. I did not see it properly. So I'll repeat this part. When somebody says that at least one root is positive. Now, what does it mean? It means either exactly one root should be positive, which we are seeing from here, So that is what the third case, or means union, which means I need to club these two results. Which result? Or both of the roots are positive, which is happening with the fourth case, which is given over here. I hope you have understood it. Similarly, if I'm asked that at least one root is negative, well, what will I do in that case? if at least one root is negative, what does it mean? It again means either one root is negative, one root is positive, or both of the roots are negative. So one root is negative, one root is positive is happening in the third case when roots are of opposite sign. So I need to take the third case union, which means either this will happen or both of the roots are negative, and both of the roots are happening found to be negative, in the fifth case. So I need to take the union of third and fifth case. Did you get that part, students? I hope you are comfortably able to understand this much conclusion, whatever has been explained so far. Let's proceed ahead with the next part, where we'll be getting more clarity based on conclusions of these two roots. For example, if I'm said that if the greater root in magnitude is positive, I repeat, if the greater root in magnitude is positive, can I say we know what is alpha plus beta? What is alpha plus beta, students? Alpha plus beta, where let's say for a while I'm assuming that the alpha is greater than 0 and beta is less than 0, but alpha and beta have this thing that the magnitude wise, the positive root alpha is greater than beta. For example, alpha is 3, beta is minus 2. So if alpha is 3, beta is minus 2, 3 minus 2 will be positive. So if the greater root in magnitude is positive, then the sum of the roots will be positive. This is what can be concluded. But along with that, what I am also aware of is that their product will still remain negative. That can be the conclusion here. So I repeat this particular part. When somebody says that the greater root in magnitude, if it is positive, for example, one of the roots is 3, the other root is negative, which is minus 2. So 3 and minus 2 are two roots. So 3 and 2, 3 is greater. I hope you can see. So the greater root in magnitude is positive. Then we know two things. Sum of the roots will be positive, product of the roots will be negative. That's again a necessary and sufficient condition for you to solve this particular part. You need not do anything else. Don't even think of this. This is again something confusing for you at this stage. Just remember this particular result. Between alpha and beta, let's say alpha is 3, beta is minus 2. Always take such examples and create your own scenarios. Well, in that case, alpha plus beta will be positive, alpha into beta will be negative. That's it. That's how you can simplify this. Next conclusion. When I say that the greater root in magnitude is negative, the greater root in magnitude is negative. Let's say minus 3 and 2. So the two roots are minus 3 and 2. Can you conclude one thing? Yes. Sum of the roots, minus 3 plus 2 will be negative. So first conclusion, sum of the roots will be negative. But again, product of the roots, minus 3 and 2. So the product of the roots is going to be negative. So again, I'll draw these two conclusions, sum of the roots and product of the roots. Just create these scenarios in your mind and develop the logic and apply that on the question given to you. And that's how you will get the answer. Did you get that part, students? Now, let's say if I am told that both the roots are 0. If both the roots are 0, well, that can happen if the sum of the roots is found to be 0. Product of the roots will also be 0, which means B and C are 0, which means I'll have a quadratic somewhat like this. Ax square is equal to 0, because in that case only x will be 0, which means both of the roots will be 0, right? Similarly, let's say if roots of the equation are 0 and minus b upon a, let's look at this from different perspective. Let's say the quadratic is ax square plus b, or rather the quadratic is ax square plus bx is equal to 0. It does not have the constant term, let's say, for a while. So can I factorize it as x times ax plus b, and I hope from here you can see it very clearly. One of the roots will be 0 and the other root will be minus b upon a. Well, that happened when c was not there. So I hope you can see this very part very clearly. Now the other part we have already discussed, that if a plus b plus c is 0, then one of the roots of your quadratic will be 1 and the other root will be c upon a. We have already discussed this particular part previously. Alright, so let's proceed further with more example, with a better question, which actually, mixes two concepts, Newton's formula and transformation of quadratic equations. So two concepts merged, and this was a question asked by JEE Mains in 2025. Let's understand this better. First of all, let's see what are we given. We are told that Pn is alpha to the power n plus beta to the power n. the moment you see, you must have this mind that now I think I may have to use the Newton's formula. We'll use it accordingly. Next, we are given P10, P9, P8. Okay, we'll see it as per the need. But along with that, I am told that we are supposed to write a quadratic which has the roots 1 by alpha and 1 by beta. So the approach could be, let's find a quadratic first which has the roots alpha and beta. And then transformation of quadratic is, I think, a very simple task for you now. So we'll do that later. But first of all, let us find a quadratic which has the roots alpha and beta. Let's assume that there is a quadratic. Let's assume that there is a quadratic ax square plus bx plus c is equal to 0, which has the roots alpha and beta, right? So this could be the quadratic. Now, whenever I have this quadratic, and if I am said that Pn is alpha to the power n plus beta to the power n, where this quadratic has the roots alpha and beta, can I use the Newton's formula? I hope you must have remembered it. The formula will say that a, b, c will remain intact, but in place of x square, x and 1, the constant terms and the variables, you can replace Pn, Pn minus 1, Pn minus 2. Do you remember that? So here, by using this Newton's formula, can I say that this quadratic can also be written as A, Pn, let's say, plus B, Pn minus 1, let's say, plus C, Pn minus 2. That result will always be there with us. Either it was a to the power alpha to the power n plus beta to the power n, or alpha to the power n minus beta to the power n. In both of these cases, this holds true. This Newton's formula stays valid. Do you remember that? Now, when I proceed further, what additionally I know or remember is, let's have a look at that part. See, I am told P1 is 1. What do you mean by P1? If I replace n by 1 here, P1 is alpha plus beta, which means alpha to the power 1 plus beta to the power 1, which is alpha plus beta, which I know is minus b by a as per our logic, but as per their logic, it is 1. Okay, so minus b by a is 1. Well, in that case, if I look at this part only, if minus b by a is 1, can I say that a should be equal to minus b or b should be equal to minus a? That's our first conclusion for the day. So let's apply that logic here. So by applying that logic, let's say I'm replacing b by minus a here. So it is a pn, then b I'm substituting by minus a. So it is minus a pn minus 1 plus c pn minus 2 is equal to 0. I hope that part is very well understood by you all. Now, why did we do this? For a while, what I know is P10, P9 and P8. Can you help me with what should I do next? Some of you might have noticed P10, P9 and P8. Something very important they have given in the context of Newton's formula to be applied a little differently. So how should I do this? How should I proceed further? I am doing one simple thing, that I'm replacing this n by 10 here. So what do I get? I get a P10 minus a P9 students plus c P8. I hope this part is very well understood by you all. Now, when I do that, what do I have next? A P10. A P10 means 123a. So I'll write it here, 123a minus, we had AP9. AP9 means 76A. So I'll write 76A here. Then what did we have? CP8. CP8 means 47. 47C. Let me just cross check it whether I have written it properly or not. AP10 minus AP9, which was 123 and 76. Yes, 123 and 76. And then 47C. So plus 47C. Yes, that is perfectly fine. Now, 123 minus 76. I think 76 plus 4 is 80. 80 plus 40 is 120 plus 3. I think 3 plus 4, 7. Yes, 47. So 123 minus 76 is 47. So it is 47A plus 47C is equal to 0. If I take 47 common, I'll be left with A plus C is equal to 0. From here, if I take the C on the other side, and if I take A on the other side, C will be minus A and C upon A will be minus 1. What does it mean? C upon A is minus 1. What does it mean? It means we are given the product of the roots. So I had sum of the roots. I have product of the roots. If I have both, can I not write the quadratic? We all can. So if I am asked to write the quadratic which has which has the roots alpha and beta, but I don't know the alpha and beta directly, but I know the sum of the roots and the product of the roots. Well, in that case, the quadratic is given by x square minus sum of the roots plus product of the roots is equal to 0, right? So what is sum of the roots? Alpha plus beta, that is 1. So the quadratic will be x square minus x plus what is product of the roots? Alpha beta, that is minus 1. So it should be minus 1 is equal to 0. Well, this is the quadratic which has the roots alpha and beta. Just a second, just a second, just a second. We are not asked the quadratic which has the roots alpha and beta. Rather, we are asked the quadratic which has the roots 1 upon alpha and 1 upon beta. Do you remember the logic to transform the quadratic? You need not do much. Just think logically, just think intuitively. What is that? Sir, let us take 1 upon alpha is equal to x. I hope you remember this process because they are symmetric in nature. 1 upon alpha, similarly 1 upon beta. So they are symmetric in nature. So 1 upon alpha is x. In that case, alpha is 1 upon x. So all I need to do is I need to substitute x by 1 upon x here. And I'll get the quadratic which will have the roots 1 upon alpha and 1 upon beta. Do you remember this method, students? I'll be applying that method. So here I'm supposed to do nothing but substitute x by 1 upon x here in this particular quadratic. Well, in that case, the quadratic will now become, I'm writing this particular portion here. I hope that doesn't bother you. So if x is substituted by 1 by x here, it will be 1 by x whole square minus 1 by x minus 1 is equal to 0, which when simplified gives you the final outcome, which should be, let's say I'm multiplying the entire expression by x square and the numerator on both the sides. So this will become plus 1. So let's say plus 1. Then minus x square upon x is minus x. And then minus x square into minus 1 is minus x square is equal to 0. If you want to solve it further, you can take minus sign common. The standard quadratic will be x square plus x minus 1 is equal to 0, which should be the final answer to this question. X square plus x minus 1 is equal to 0, I think is given in the option A. Did you get this part, students, very clearly? How simple it is, how interesting it is, and how can you solve these category of questions? And as you can all see constantly that such questions were always asked by JEE Mains and Advanced in the last previous years, or they are always very much obsessed with this Newton's formula, location of roots, quadratic equations, transformations, condition on the roots. These, ups and downs they keep doing with the roots, and that's how they basically try to confuse you with the questions based on quadratic equations. So I hope so far you must have realized and understood that this chapter is not tough at all. This is absolutely a very simple chapter. Just learn all the concepts which are very simple to understand, apply them and solve the questions, and questions are doable. Any sort of questions is doable in this category of chapter. Although sometimes the calculation may be there, but that is something which is expected out of you if you are a JEE aspirant, right? Now, let us proceed further with some more concepts where we talk about condition for common root. Don't look at this particular part, just learn one thing, that if you are given two quadratics, right? Let's say I'm given two quadratic equations. One of the quadratics is ax square plus bx plus c is equal to 0. The second quadratic is, let's say, dx square plus ex plus f is equal to 0. And what am I told? I am told that these two quadratics have one common root. Let's say this quadratic has the root alpha and beta, and this quadratic has the root alpha and gamma. Now such questions are asked. Modus operandi says something else, but intuitively you should do something else. What is that approach? You will see the term in x square in both the equations. So both of the equations will have a term in x square. Just do one thing, ensure that the coefficient of x square becomes same in both the equations. And I hope you know how to do that. You have learnt how to solve equations, linear equations in two variables by using elimination. That's exactly what I'm asking you to do. Let's say for a while, x square is a variable, x is a variable. So let's say for a while, x square is x is y. So this is an equation in two variable, ax plus by plus c. This is another equation, dx plus ey plus f. And I am asking you to eliminate the term in x square. How will you do that? The logic is very simple. Can someone help me with that? The logic is very straightforward, students. What you do is the coefficient of x square, which is a here, you will multiply this equation by a. So what will it become? It will become AD x square plus AEX plus AF is equal to 0. Then the coefficient of x square is d here. You multiply this equation by d. Then in that case, it becomes AD x square plus BD x plus CD is equal to 0. Now I'm asking you to subtract this from this. So I hope you can see ADX square is getting cancelled. So do you realize this is same as that's elimination method which we have discussed. Now what I'll get here is AEX minus BDX. So AE minus BD whole times x is what I'll get. What will I get from here? AF minus CD. I am taking that part on the other side. So that will become CD minus AF if taken on the right hand side. What will be the x? What will be the value of x from here? So if I find the value of x from here will be, CD minus AF divided by AE minus BD, right? That will be the value of x. Now this value of x, you put either here, I repeat, this value of x, you may put either here or there. And there or that's how you will find the condition if both of the equations have one root common. Although if I do it now further algebraically, it will look very cumbersome, very complicated, very tough. But in reality, the question will be done through this particular method. What did I do? I solved both of the equations where I tried eliminating the term with x square, and that's how I got the value of x. Now that value of x which you have received can be put either here or here, and that's how you will find or do what is needed to be done as per the question. But this is going to be the approach, this is going to be the modus operandi whenever you are asked to solve a question based on the part where it says that two quadratics have exactly one root common. That's exactly what I'm asking you to do. You need not learn this condition. You cannot remember or memorize all these formulae which are being taught. So try to have those logics with you in the examination hall. Because trust me, this examination, JEE Mains or Advanced, is not much about learning or memorizing. They are not assessing your ability to learn, that how well can you memorize, how well can you cram, how well can you mug up things. No, that's not they want. What they want is that how logically sound you are, how logically intelligent you are, what kind of brain you possess. That if sometimes some concepts, some theory, some logical part is given to you, are you able to apply those concepts in solving problems? So how good you are at solving problems is what they are trying to assess. They need good brains. They don't want those kind of brains which are good at learning, which are good at memorizing, which are good at cramming. Of course, you need to learn concepts which you can memorize by practicing questions, but not everything needs to be crammed or mugged up. That's, I hope I'm trying to make you understand. What you simply need to understand is anything can be memorized. Google has everything. You can memorize things. You need not do it at this stage in this era. Basically, what you need to understand is you should be logically sound, and that is simply what they are expecting from you. I hope the part gets conveyed to you very clearly. So I hope you have understood the logic. If I'm told two quadratics have the same common root, have one common root, then what are you supposed to do? Eliminate x square, get the value of x, put that value of x in either of the quadratics, and you'll get the answer what is needed to be done as per the question. Apply this modus operandi, that's all. Now, let's say if I'm told that if there is a quadratic which has both the roots common, if let's say there are two quadratics which have both roots common, well, can that happen? Yes, there are two quadratics, both of the roots are common. Some of you might say, sir, if both of the quadratic have the same roots, then they are not two different quadratics, they are the same quadratics. Exactly. My point is also same. If there are two quadratics and they have the same roots, if they have the same roots, both of the roots are same, then why would they be two different quadratics? They should be same quadratic. And if they are the same quadratic, well, that in that case, A and A dash, B and B dash, and C dash should be either same or proportional. proportional, because if this quadratic is x square plus x plus 1 and the other quadratic is 2x square plus 2x plus 1, then 2 can be taken common. Both of the quadratics will become same and they'll have the same root. They'll have the same root. So I repeat, if two quadratic equations are given, and it is told that they have the same roots, then their coefficients must be proportional. Their coefficients must be proportional. Their coefficients must be proportional. I hope you are understanding it logically. This is the required, necessary and sufficient condition to solve questions based on that. Now we come to a very crucial part where we discuss that, let's say, if you are asked to draw the graph of quadratic expression, although this is not a board examination where you will be asked to draw quadratic expressions graph, but you may need it as per the need of the question. So question may ask you to deal with graph of the quadratic or something like that. Well, in that case, how will you finally come up with your answer? That minima is asked, maxima is asked, its curvature is asked, its value in certain domain is asked. So all those conclusions can be brought when you know how will you draw the graph of a particular quadratic. See, the concept remains very simple. You are given y is equal to ax square plus bx plus c, where a is not 0, mind you students. Well, when you convert it into a perfect square, now how do you convert it into a perfect square? Let me just try and show it to you here. Let's say I am told that y is equal to, I'm really sorry, that y is equal to, that this y is equal to ax square plus bx plus c, right? Now this is what I am given. So now how do I proceed further? So basically I take a common from this. So when I take a common from here, I am taking a common from here. I'm left with x square plus b upon a times x plus c upon a, right? Now I'm trying to make it a perfect square. How will you do that? I'm trying to apply the identity a plus b whole square. So that is a square plus b square plus 2ab. So I'll try to have those three terms here. How can I have that? I hope you can see it very clearly. I can use some arrangements here. What are those arrangements? Pay attention to this particular part. First of all, a square can be treated as x square, right? Now I need 2ab. So if I multiply this part by 2, I need to divide it by 2. So can you see 2ab? What is b? B is b upon 2a is x and 2 is 2. So I have a square, I have 2ab. What is b? B is b upon 2a. So I need b square. What is b square? To make it a perfect square, you need b square. B square will be b by 2a whole square. Now if I have taken b by 2a whole square, which I cannot do by myself, so I need to subtract this to balance the equation. So I'll subtract b by 2a whole square, which can be written as b square by 4a square. I hope that part makes complete sense, whatever I have done so far. Now, the part remains very simple. A square plus b square plus 2ab will become a plus b whole square. So this now will become y is equal to a times whole of a plus b whole square. What is a? A is x. What is b? B is b by 2a. So x plus b by 2a whole square is what I'm dealing with. Next part. What am I now left with? C by a and b square by 4a square. So can I write it as, see, this c by a I'm keeping here as it is, and this b square by 4a square I'm keeping here as it is, right? So this is what we are now left with. Now, if I club this particular part, see, this is 4a square, this is a. So I'm multiplying 4a here, I'm multiplying 4a here. So 4a square becomes the LCM. And there it becomes 4ac minus b square. So can I write this part as y is equal to a times x plus b by 2a whole square minus, I have taken minus sign common. Then do I, or can I say it should be b square minus 4ac upon 4a square, right students? I hope this part is very well understood by you all. Why did I do that? Because b square minus 4ac will be d. Now if I simplify this, can you see that this when simplified will look exactly like this? See, this part, a is there as it is, x plus b by 2a square is there, yes it is there. Then this part is minus d by 4a square, this is exactly what we have. So if I take this d by 4a square on the other side, this a cancelling this a will leave you with y plus d by 4a on the left hand side, and x plus b by 2a whole square times a on the right hand side. Now, why did we get this? What is the point of having this? What is the advantage of having this? Let's understand that part. Let's say if I write y is equal to 4ax square. When you study conic sections, there you study that this represents a parabola. This represents a parabola where if, let's say for a while, if I say that if a is positive, it will be an upward facing parabola where this will be the y-axis and this will be the x-axis. So this will be an upward facing parabola which will have its vertex at 0, 0. Now, if I use the concept of shifting the origin, which you study in coordinate geometry when you deal with Cartesian system or points, there I am not dealing with a quadratic which is y is equal to 4ax square. It looks a little different. How does it look? It looks like y, but originally y here is y plus d by 4a. 4a is not 4a, it is simply a. And what is x square? X square is x plus b by 2 whole square. Which means I have shifted origin to minus d by 4a and minus b by 2a. Rather, in a better language, I have shifted the origin to minus b by 2a comma minus d by 4a. I hope you know this concept of shifting the origin, which if you don't bother. We'll discuss this when we discuss the chapter system, shifting of the origin. Don't worry much about that. So if I come back to this part, what I have done is, let's say for a while, to make you understand, I am keeping a positive. So you are getting a quadratic. Where its vertex from 0, 0 to, I have shifted at minus b by 2a comma minus d by 4a. So this becomes minus b by 2a comma minus d by 4a. And this vertex now, if it has become, the parabola will remain the parabola, but it will have its own x-axis somewhere, it will have its own y-axis somewhere. And what I have still taken is that the a remains positive. Well, in that case, this curve represents the graph of y plus d by 4a is equal to a times x plus b by 2a whole square. So first of all, I am trying to make you understand that this curve represents the graph of a quadratic expression where we have taken a to be positive. We have taken this assumption in mind that if a is positive, you will have this quadratics graph drawn somewhat like this. Although the graph will not always be like this, it will sometimes touch the x-axis, or it may be sometimes staying above the x-axis, or it may sometimes intersect the x-axis. That may happen as per the need, as per the requirement, as per the conditions which we'll discuss. But what you need to understand is that the quadratic expression has its graph as a parabolic curve, either upward facing or downward facing. If a is positive, it will be upward facing. If a is negative, it will be downward facing. Now, what additional conclusions can be drawn? That is what we'll be discussing. Please pay attention. In a very simple language, I'll give you a complete clarity about the graph of a quadratic expression or equation. So expression is what we'll be dealing with. Let's say this is your coordinate axis, x-axis and y-axis, right? I am told that a is positive and d is positive. I am drawing the graph of, I will always draw the graph of y is equal to ax square plus bx plus c. So this is not what I'll be constantly telling you, but I'll be drawing the graph of y is equals to ax square plus bx plus c. And the first case which I'm taking is a is positive, d is positive. First condition, a is positive, upward facing parabola. D is positive, which means two distinct and real roots. Can you help me? If I have two distinct and real roots, what will happen? If there are two distinct and real roots, the curve must intersect the x-axis at two distinct points. Because wherever the curve cuts the x-axis, wherever the curve intersects the x-axis, those are the points where the roots or the solutions of the equations lie. Which means if I were to draw the graph of the quadratic, this may look somewhat like this. This is the case when a is positive, upward facing parabola, d is positive, which means two roots. First point where it intersects will be alpha comma 0. Second point where it intersects the x-axis will be beta comma 0. So these are the two roots, and exactly between alpha and beta, that is this point, will be its vertex, which we have already discussed, will be minus b by 2a comma minus d by 4a. So what we have understood so far is that this quadratic will be positive for all the values between minus infinity and alpha because it was above the x-axis. But this quadratic will be negative between all the values of alpha and beta because it was below the x-axis. And this quadratic will again be positive, for all the values of beta and infinity because there again it was above the x-axis. If I were to talk about its range, it will be minus d by 4a to infinity because this will be its minimum value minus d by 4a and it will go up till infinity. So a lot can be deduced by looking at the graph. And how can you talk about the graph? If you know a and d. So discriminant and a play amazingly crucial role in deciding a lot about the graph of a quadratic expression. Questions are there, location of roots gets decided based on this particular part. So a lot of things are concluded once you have started understanding the graph of quadratic expressions. So I am discussing all the cases. Pay attention to everything what we are discussing here because every case has its own speciality. With every case, you get a lot more clarity about quadratic expressions, its graph, and you delve much deeper into the concept of location of roots, which is equally important as Newton's formula. It is very widely asked, very amazingly asked, and location of roots is a very interesting concept. If you understand this particular part, you can talk very well about location of roots. So location of roots is somehow or somewhere dependent on this particular part. So pay very much attention to this part where we are discussing graph of the quadratic expression. So I hope this part makes complete sense. Let's say again, if I take the second scenario where you are having x-axis and y-axis, you're basically Cartesian coordinate plane, and there you are given again a quadratic, but this time a was positive but d was 0. Can you help me? When d was 0, what can you conclude? So again, we are talking about this quadratic y is equals to ax square plus bx plus c. But if this was the quadratic y is equals to ax square plus bx plus c, which I'm treating as a function f of x, then this time, if d was 0, if the discriminant was 0, can I say the roots will be equal? They'll be real, but they'll be equal. And if the roots are equal, they are minus b by 2a. So this time the graph will stay upward facing because a was positive, but d being 0 will not make it go below the x-axis because at this point d will touch the x-axis where both of the roots will lie, which are going to be equal, alpha and beta, which is the vertex of the parabola, which is minus b by 2a. So in this case, I'll say that the parabola is always above the x-axis. At one point only it touches the x-axis. So this case says that y is either greater than or equal to 0 for all x which are real. Because the graph is always above the x-axis, just touches this x-axis at this point only. So y is 0 at this point, otherwise it is always positive. So this can be concluded. I hope you are understanding this particular part. Very simply, can I not say the third conclusion will be there is an upward facing parabola and the x-axis and y-axis may go somewhat like this. Y-axis can be anywhere, right? I'm just drawing this y-axis here as a part of my practice, but this y-axis can be here, here, here. It does not play any crucial role as of now regarding what we are discussing here. But if a is still positive and d is negative, a positive, upward facing parabola, d negative, no real roots. No real roots means graph does not intersect the x-axis. So I need to ensure that it stays above upward facing parabola and it does not intersect the x-axis. If it does not intersect the x-axis, the vertex still remains minus b by 2a, comma minus d by 4a. But this time what you need to remember is that the graph is lying always above the x-axis because there is no real root. And if there is no real root, we can say that y is positive for all the real values of x. Remember this as a result. A very crucial property it is. A lot of inequalities are formed based on this result, where you will be using that if somebody says that this is a quadratic which is positive for all the real values of x, what will I conclude? That its discriminant should be negative and its coefficient of x square should be positive. These are the two conclusions which should come into my mind if something like this is said to me. Are you getting these results, students? Are you understanding these conclusions? Well, In the same fashion, what we have discussed so far, three more cases arise. What are those three cases? I am directly telling you those three cases now. Let's say here I have drawn this case here like this, and I have drawn this case here like this, and I have drawn the third case here like this. Can you help me with these three cases? That what do they signify or imply, or what can you conclude with these three scenarios? First of all, can you see in all these three cases, they are representing a downward facing parabola. And if they are representing a downward facing parabola, that means in all these cases, A is going to be negative. This will remain common. Upward facing parabola, A should be positive. Downward facing parabola, which means A should be negative in all these three cases. What do they imply additionally? Well, here I can see two distinct real roots. Two distinct real roots means discriminant should have been greater than 0. I can see the graph intersecting the x-axis. Rather than intersecting, should I not use the word touching the x-axis? Because x-axis is behaving as a tangent here. So here, if it is not intersecting, rather touching at one point, which means it has one real root, or rather both of the roots are repeated, which means common, which means same. So here I'll have alpha and beta both to be equal. Here alpha and beta were distinct. So if both the roots are equal, this is the case which represents D to be 0. The third case, students, here the graph is not intersecting or touching the x-axis at all. It is always lying below the x-axis, which means no real roots at all, which means D should be negative. The vertex, if any point needs to be said about the vertex will always remain the same, minus b by 2a comma minus d by 4a. But previously when a was positive, that was minima. Here, when A is negative, this vertex will be the maxima of this parabola. Minima, maxima. Getting my words very carefully, students. Third part, here again, Y was negative, positive, negative. Y was almost negative except for this point where it was 0. Here, Y is always negative. That's again a very important conclusion, that in this case, Y is always negative for all the real values of X. That's again a very important conclusion you should remember as a result from here. So if Y is less than 0 for all the real values of X, Y means the quadratic, then that can happen when discriminant is negative and A is negative. I hope you'll remember these particular conclusions which I'm trying to make you understand. This is again a very important formula, or rather learning, which you should have in your mind. Can we talk about this particular portion with an example? Can we delve deeper into this particular understanding with one more example? Whatever we have studied so far regarding graph of the quadratic expression, can that be applied in a question? Well, you have a question right there in front of you. Give it a try, and then we'll discuss its solution together. By the time you pause the screen and solve it, I am also starting to solve it. So first of all, let us understand this particular question here. What does it say? Alpha and beta are two distinct roots. Okay, so they are two distinct roots, mind you, students. Then of which equation? This equation, which is x square minus something times x plus 1. Okay, that's fine. I am told this expression, which is the coefficient of x, is also quadratic in T, where T can be a real number. Are you not seeing what are we given further? That an is given as alpha to the power n plus beta to the power n. Again, what is coming into picture? The Newton's formula. Can you see that? The Newton's formula is getting used again. So are you not realizing how important that is? They use it almost everywhere, right? So they are so much in love with Newton or Newton's formula that they constantly keep on asking, or they push it anywhere. They just merge it with any question. This particular concept, Newton's formula. I hope you can see it getting utilized almost everywhere now. A question asked by JEE Mains in 2024. It says, what could be the value of this expression? Okay, what could be the value of this expression? Let's try and find that out. How do I do that? First of all, if I am told an is alpha to the power n plus beta to the power n, what do I know? I can use an in the quadratic I'm given. Which quadratic? This quadratic. So can I write this quadratic as an minus t square minus 5t plus 6 an minus 1 plus 1, which means an minus 2. I hope I need not explain this part. How did I write this? You know the Newton's formula now. What did I do? X square, which means an. Then this coefficient remains as it is because coefficient of x square was 1 here, so I did not write that 1 here. Then x means an minus 1. Then this 1 means 1 into an minus 2, because what is an? Alpha to the power n plus beta to the power n, which are the roots of this quadratic. I hope no confusion on that so far. Now, here, what am I asked? 23, 25, 24. Can I do something here? Can I do something here? Yes, we can. Let's say by looking at this expression whose value I'm asked, let's say I'm replacing n by 25. I'm replacing n by 25. What do I get? I'll get a 2025, right? Then minus of minus of t square minus 5t plus 6. If n was 2025, it should be a 2024 plus this is a 2023 is equal to 0. I hope this part makes complete sense. This is very well understood and perfectly digested by you all. Then what do I do next? I take this part on the other side and I keep them on the left hand side. So here I'm left with a 2025 plus a 2023, and when I take this on the right hand side, I keep this on the right hand side and I bring on the left hand side in the division, because there it is in the multiplication. So here it will be this expression divided by a 2024, which is equal to t square minus 5t plus 6. Did you see something very interesting here? Did you notice something very amazing here? This is the expression we are looking for, but this expression has now turned into a quadratic, t square minus 5t plus 6. Okay, that's fine. We are asked the minimum value of this. We are asked the minimum value of this, which is equal to this, which is equal to t square minus 5t plus 6. So I need to find the minimum value of this expression. So if I find the minimum value of this expression, that will be the minimum value of the expression which I'm looking for. And here in this expression, I am told that t can take any real number. So I need to find the minimum value of this expression where t can take any real number. Now, do you not think, do you not realize, or are you not understanding that this is again nothing but an application of graph of quadratic expressions? Can you all see that happening over here? A very straightforward question on graph of quadratic expressions. How do we do that? Let's have a look at that particular part. See here, I will be writing a quadratic from here. So let's forget this. Let's just try and find the minimum of t square minus t minus 5t plus 6. So let's say y is equal to t square minus 5t plus 6. We know coefficient of t square is 1, upward facing parabola, which means it will have its minima at minus b by 2a. The minimum value will be minus d by 4a. Do you remember the vertex of the parabola we have discussed so far? Sir, we have forgotten that. We don't remember formulae. We just forget everything. We don't remember all these things. We are already very much pressurized. The exam is right there in front of us. We are not able to remember everything. Okay, you forgot it? Forget it. That's perfectly fine. Do we have any other method? We have 3 methods. Second method, convert it into a perfect square. There you'll get the answer. Sir, we don't want to apply that much efforts. Converting into a perfect square is totally a different task. We don't want to do that. Okay, third method, differentiation, maxima, minima, application of derivatives, which you study in physics as well. Can we use that? Yes. So differentiation says find its derivative. What will be dy by dt, because it is a variable it is an expression with variable t, right? So dy by dt will be 2t minus 5. Now we find the critical point. So dy by dt, I'll put equal to 0. dy by dt, if I put equal to 0, I'll put 2t minus 5 is equal to 0, from where I'll get the value of t as 5 by 2. Now, so far I know that t is generating one value as its critical point, and it will have its minima there because it is going to be an upward facing parabola. Upward facing parabola will have a minima. So I'll find the minima at t is equal to 5 by 2. You need not check the, you need not do the second derivative test to check whether it will have minima or maxima. You need not do that. Please understand. So I'll replace t by 5 by 2 here. So if I replace t by 5 by 2 here, I'll get the value of y, which is the minimum value of y, which will be 5 by 2 whole square minus 5 into 5 by 2 plus 6, which I am sure you all are able to do, and that will be the minimum value of this expression, which will be the minimum value of this expression, which I am sure you can do by yourself. So that part is doable, a simple calculation we are left with, which I'm sure you can do. My intent was to make you understand the concept that how should you do these category of questions, right? So all the learnings, whatever we have been discussing so far, are getting converged, are getting combined and clubbed, and we are now moving towards the culmination part of this particular chapter. Although this is not done yet, a very important part is remaining: location of roots and some higher degree equations with some more theorems and properties. And I'm sure you're sticking here, and you're still here with this part of this particular video, and you're learning and applying all these things in these questions which we are discussing. So let's now move to the next portion of our video, where we'll talk about the wavy curve method. Mind you students, it is not baby curve method, it is the wavy curve method. How do you apply it? Let's understand that part with an example. For example, we are given an expression which is factorized first of all, and all the factors are, let's say, linear. They are having degree 1. And I am asked to suppose, I'm asked to solve this particular inequality. So how do we do that? Well, before you get started, first of all, ensure that all the coefficients of x are 1, which means they should be positive and 1. How do we do that? All I am having is x, x, x. They are having coefficients 1, but this is having coefficient 2. Although it is not a problem, after a certain amount of practice, you can solve this particular question from here only. But at this stage, to keep it simple, let's say I take this 2 common from here. So I'll be having this inequality as x minus 1 by 2. Then it will be x minus 1 whole square, then x minus 2 whole cube divided by x minus 4 to the power 4 greater than 0. That 2 goes to the other side and becomes 0 because 2 was positive. The sign of the inequality will remain intact. This is what I'm sure you know and aware of. Then what do we do next? Then you draw the number scale. You plot the points on the number scale. Which points, students? The points are very simple. These points which you achieve by putting these simple factors equal to 0. What I'm talking about is a very simple fact that this is the number line which has the points from minus infinity to infinity. Now, if I start looking at this part, I have 1 by 2, 1, 2 and 4 from here. Well, plot these numbers 1 by 2, 1, 2 and 4 on the number scale. So 1 by 2 being the smallest can be here. Then I can have 1, then I can have 2, and then I can have 4. So these are the 4 points I have plotted: 1 by 2, 1, 2 and 4. Now, you begin with the rightmost section, 4 to infinity. I'll put a plus sign over here. That's what you do. Once you have put a plus sign over here, look at this 4. Where did you get this 4 from? I got this 4 from this particular factor. What was there with this factor? This factor had a power 4, which was even. This factor had a power 4 which was even. So if this power 4 was even, when I move from 4 to 2, that means in this chunk the sign won't change. The sign will still remain positive. Now let's look at this 2. Where did I get this 2 from? I got this 2 from this factor x minus 2. This factor x minus 2 had this power 3 which was odd. So if that factor had a power odd, then the sign changes, which means if this was plus here, then between 2 and 1, the sign will be negative. So I'll be having a negative sign here. Then I'll move to this 1. Where did I get this 1 from? X minus 1. This has a power 2, which is even, right? So if this power is even, the sign wouldn't change, which means this will still remain negative. which means for all the values of x between 1 by 2 to 1, this expression will give me negative values. That is what I'm trying to conclude here. Then when you proceed further, look at this 1 by 2. I got this 1 by 2 from this x minus 1 by 2. This had the power 1, and power 1 we all know is odd. So if 1 is odd, the sign must change, which means if it was negative here, this will become positive. What we have concluded so far is that between minus infinity to 1 by 2, between 2 to 4, between 4 to infinity, if you take any values of x and put them here in this expression, it will be positive. And if you take any value of x between minus 1 by 2 to 1 or 1 to 2, this expression will be negative. So this is the advantage of wavy curve method. You need not think much in detail or try some values. You can directly conclude it like this. What do we do next? Very simple conclusion. I want it to be positive. Yes, I want it to be positive. When am I having it to be positive? Sir, between 4 to infinity, between 2 to 4, and between minus infinity to 1 by 2. So you have your answer. The answer, which means x belongs to, I am looking for all those values of x for which this expression is positive, greater than 0. So this is positive between minus infinity and minus 1 by 2. So minus infinity to 1 by 2, although 1 by 2 is not included, because when 1 by 2 is included, it becomes 0, which I'm not supposed to conclude or include. Then apart from this, I'm supposed to take all the values between 2 to infinity, excluding 2 and 4, because at 2 and 4, at 2 it becomes 0, and at 4 it becomes not defined. So I'll be taking all the values between 2 to infinity, but I'm supposed to exclude 4. So I have taken union of this and this, but in this 4 also lies that I have excluded by using this particular expression. So I hope you have understood how are we using this wavy curve method, how should you apply this, and how can you solve questions based on it. And if you have learned this wavy curve method, let's try and solve another question based on quadratic equations asked by JEE Mains in 2024. So wavy curve is a very crucial method. This method you will keep using throughout these different chapters you'll be studying in JEE Mathematics. Almost each chapter asks you questions based on inequalities, and whenever inequalities are there, wavy curve will play a crucial role. Now, let's have a look at this particular part. Let S, okay, so we are told that there is this S, and this S is a set of positive integral values of A. So there is a set S which contains values of A which are positive integer values of A. Okay, we'll remember that. For which this expression, now what does this expression imply? It has something in the numerator, something in the denominator. Both are quadratic in x, although here in the numerator along with x we have another arbitrary constant which is A, which is somehow defined here. Then we are told that this expression is negative for all the x which are real. Now something must have struck. Now this is negative for all x which are real. Then the number of elements in S are to be found. JEE Mains 2024, a very simple question if you know the concepts, because everything is simple if you understand it. If you have understood it, things become simple. So learn it, understand it, and then you'll be able to solve it. Now, first of all, I'm given an expression, right? I'm given an expression. Now, how do I deal with this particular expression? Let's talk about that part, right? So basically there are two parts, the numerator and the denominator. Let's look at the denominator. The denominator is x square minus 8x plus 32, right? So I'm looking at the denominator x square minus 8x plus 32, right? Let's say this is an expression. Let's call it an expression. Now, if I'm looking at the denominator, let's find its discriminant. Let's just find its discriminant. Why am I doing it? You may realize it later, but let's try and look at its denominator, that discriminant. That will give me more clarity about it. So if I work on its discriminant will be b square, which is 8 minus 8 square, which is 64, minus 4ac. So 32 into 4. Now what you need to understand is 32 into 4 is greater than 64. So without even calculating, I can conclude that d will be negative, which means this quadratic is having its d negative. First conclusion. Second conclusion, the coefficient of x square is 1, which means it is positive. So d is negative here and a is positive here. Can you help me with its graph? Can you not see that its graph will lie above the x-axis? Because d is negative, no real roots. A is positive, upward facing parabola. So if D is negative and A is positive, can I not say that I have a very good clarity about this quadratic expression, that this quadratic expression will always be positive for all the real values of x, because because I am seeing its D to be negative and its A is already found to be positive. So yes, that can be concluded. Now please understand, numerator upon denominator needs to be negative. The denominator is always positive. So if this is always positive, so something upon positive should be negative. When will it be negative? It will be negative if this is negative. If the numerator is negative, because this is positive, this needs to be something so that this becomes negative. So this will be negative only when the numerator is negative. So what I need to ensure is that the numerator should be negative. So my conclusion here is that I need to ensure that the numerator should be negative, because only then negative upon positive will be negative, and that is, I'm told, for all the real values of x. Okay, so now let's work on numerator. What is numerator? Numerator is ax square plus 2 times a plus 1 times x plus 9a plus 4, and I'm asked to keep it negative for all the real values of x. Mind you, students, for all the real values of x. That's a very important observation you must have made. Now, there comes a catch. There comes a very good observation if you make. The question is done. The question is done within seconds if you understood the next part. What is the part where you may end up consuming a lot of time, or if you have noticed that part, the question is done within the next 10 seconds. How? Let's have a look at that part. This is the quadratic expression, and I want it to be negative for all the real values of x. If I want a quadratic expression to be negative for all the real values of x, well, that can happen when the coefficient of x square is negative and the discriminant is negative. I want it to be negative for all the real values of x. Well, that can happen when the parabola is downward facing and it always lies below the x-axis. Well, that happens when the coefficient of x square is negative, downward facing parabola, and discriminant is negative, which means lying below the x-axis, it does not even touch the x-axis, right? There is a catch. What is the catch, students? If you have noticed this part, the question is done. The job is done. Trust me. How? If you can see this part, the coefficient of x square, we want it to be negative. The coefficient of x square, we want it to be negative. The coefficient of x square should be negative. That is the bare minimum condition you need to have. That means to make this happen, to make this expression negative for all the real values of x, the coefficient of x square, which means a, should be negative. Which means a should be negative. Now read the question again. What is the question? S be the set of positive integral values of a. S was the set of positive integral values of a, whereas we have already concluded that further, even whatever happens with D, we need not even delve into that, because first condition is that a should be negative. And it is asking you the positive values of a. It is asking you to find the positive values of a for which this happens. But as per my observation or understanding, this will happen first of all when a is negative. Then there comes the second condition, which I am not even interested in finding or solving, because this is the contradiction here. It is asking you to find the positive values of a where it says a should be negative first of all, which means a cannot be positive. So there is no positive value of a. And if there is no positive values of a, how many elements does S contain? 5, null, 0, void, empty. There is no a which is positive, which will make it happen. Did you get my point? It's very simple observation, students. So first of all, I can very clearly see that there is no such a which is positive also and which will make it happen. No, that cannot happen as per the condition given here. So there is no a which will make it happen. No positive way which will make it happen. So if I'm asked the positive values of a, no, there is no positive a, which means number of elements in S which contains positive values of a will be 0, no, nil, nothing, 5, right? So answer should be option A. Let us proceed further. Let us understand some more important results. Let us talk about some more crucial results. Well, students deal with modulus sign. Students deal with, this particular expression where they are asked to deal with either quadratic or modulus. And trust me, they behave same. they almost behave same when you deal with either x square or mod x. So those are the conclusions we'll be discussing now. Because by looking at these results only, you can crack a lot of conclusions from your questions. What are those conclusions? For example, let's say I ask you to find the solutions of x squared less than 9. Now there are two ways. You write it as x square minus 3 square to be negative. From here you can say that x plus 3 times x minus 3 should be negative. From here you will draw the wavy curve, which will say minus 3, 3. You will say plus, minus, plus. Since it is negative, it will be between minus 3 and 3. So x should lie between minus 3 and 3. I am wanting to make you understand that this is not what you should always do. No, avoid doing this. Avoid doing all of this. No, don't always do this. Learn this as a result. What is the result? If x square is less than 9, so basically what I'm solving is x square is less than 3 square. So if x square is less than a square, always remember x will lie between minus a and a. That's the conclusion number 1. What I have said is that x square behaves as mod x in this inequality sense. So here, let's say had I given that you need to solve mod x less than 3, the same logic will hold true that you need to take the modulus of a number such that it is less than 3. I hope you're realizing I cannot afford to have any number less than minus 3 because modulus of those numbers will be positive or greater than 3, and I cannot afford to have any number greater than 3 because modulus of those numbers will also be greater than 3. So what I can conclude from here is that x will lie between minus 3 and 3. That's exactly what I'm trying to make you understand. Whether x square is less than a square or mod x is less than a, x will lie between minus a and a. Remember this as a result. First conclusion. This is used often, very often. Now, apart from this, there is another result. What is the second result? What is the next result we are supposed to remember or learn? Let's say I am given x square is greater than 9. Again, wavy curve can be applied. No, don't do that. Here, I'll have x square greater than 3 square, right? When x square was less than 3 square, x was lying between minus 3 and 3. So, when we have x square greater than 3 square, I'll have x either less than minus 3 or greater than 3. That's all. So, here, I'll conclude that x should be either less than minus 3 or x should be greater than 3. Remember this also as a result. The same logic is applied when you are given mod x. Let's say I'm told that mod x is greater than 3. So I need those numbers whose mod when taken gives you a number greater than 3. So if I take any number less than minus 3, they'll have their mod greater than 3. Or if I take any number greater than 3, they'll have their mod greater than 3. I hope you're understanding this on the number scale. So from here, I can conclude that x will be either less than minus 3 or x will be either greater than 3. These are some very basic conclusions or results which you should remember, memorize or by heart because they are very often used. So with certain amount of practice when you're solving questions, you will start applying these learnings. Not just that, there is one more very crucial learning. Let's say if I were to say that x square lies between 4 and 9. Let's say I'm told that x square lies between 4 and 9. So two conclusions. I'll say x square lies between basically 3 square and 2 square. So it should be greater than 2 square and it should be less than 3 square. So from here I'll have a conclusion. From here I'll have a conclusion, and those two conclusions can be joined because I'll take the intersection there. See, I'll solve this first when I'm told x square is greater than equal to 2 square, which means x will be either less than minus 2 or greater than 2. But that comes with another constraint. What is that next constraint? That x square should be less than 3 square, which means x should lie between minus 3 and 3. I repeat, when this part is solved, when the first part is solved, it says that x square is greater than equal to 2 square. So this is minus 2, this is 2. When x square is greater than equal to 2 square, what does it imply? It implies that it should be either less than minus 2 or it should be greater than 2. What we have learned so far in the previous slide. But it also says that x square should be less than 3 square. When it says x square should be less than 3 square, it means there is minus 3. If x square is less than equal to 3 square, I'm repeating, there was an equal sign here. So I'm supposed to include this minus 2 and 2. I'm really sorry. I didn't notice that part. So here I'm supposed to include minus 2 and 2. Second part. x square should be less than equal to 3 square. So if it is less than equal to 3 square, x must lie between minus 3 and 3, right? So if x is lying between minus 3 and 3, can you see the intersection happening over here? What is the intersection part? Minus 3 to minus 2 and 2 to 3, including all minus 3, minus 2, 2 and 3. So my conclusion will be that x will lie between all the values between minus 3 to minus 2, including both, or 2 to 3, including both. So did you get my point? We'll not be doing all of this again. I hope you must have remembered or learned the result that from here, I will always conclude that x will be between minus 3 to minus 2 or 2 to 3. So this is what you're supposed to learn. Remember or write right after this step. Don't do all this time and again. It is time consuming. This is a general result which you should start practicing or learning after a certain amount of practice, of course. The same result should be learned when mod x is given. Let's say I'm told that mod x is greater than 2 but less than 3. Again, same logic. When mod x is greater than 2, it means x is either less than minus 2 or greater than 2. When mod x is less than 3, it means x should lie between minus 3 and 3. I need to club these two. I need to take the intersection of these two. So my answer will again remain simple, that x will be either lie between minus 3 and minus 2, or it should lie between 2 and 3. But this time, I'll not be including any of these because no equality is given. Let's say I'm given an equal sign here. I'm given an equal sign on 3. So what will I do? The only change I'm supposed to make is I'll use this closed bracket over here. The closed bracket over here, minus 3 and 3. I hope you're realizing why. Because this time, mod x can afford to be 3, which means minus 3 and 3 should be included. Are you getting this point very clearly, students? That what are we doing? Why are we doing all these parts, all these conclusions, whatever we have discussed so far? With that, I hope this conclusion we have already discussed so far. Now let's move to the other part, where we finally talk the most important concept, or rather equally important as Newton's formula, which is location of roots. Questions are framed, questions are asked on it, and you are supposed to solve questions based on it. For example, let's say there is a case where I'm told that there is this quadratic equation, fx is equal to 0, ax square plus bx plus c, let's say for a while, and both of its roots are less than k. Let's say there is a quadratic. The quadratic will be either upward facing or downward facing. So two cases are going to be there. What I know is if it is upward facing, the coefficient of x square will be positive. If it is downward facing, the coefficient of x square will be negative. Now again, two more cases. In each of these cases will arise that discriminant either will be greater than 0 or equal to 0. I'm taking greater than 0. I'm not taking equal to 0 as of now, just to keep it simple, but equal to 0 can also be there. So let's say x-axis goes somewhat like this. This is the x-axis, right? So this is the x-axis. This will be alpha. This will be beta here. I repeat, this will be beta here, or in this case, this will be alpha and this will be beta right here. Now the third part, what am I asked? I am asked to keep alpha and beta less than k. What am I asked? That there should be a number k which should be greater than alpha and beta. That's a case, right? So how will I think? I'll say, let's say k lies here. I'll say in this case, let's say k lies here. So what will happen? First condition, do you not think that I want two distinct or equal real roots? Well, for that to happen, make that happen, I need to have discriminant greater than equal to 0. Because if discriminant is greater than or equal to 0, I'll have two roots. Then only I'll be able to compare that these two roots are less than a given third number, right? So that's the first case I'm supposed to apply or think of. That's the first condition you must think of. Second condition, do you not think that at this k, if I find f of k, let's say I find f of k, at this k, let's say I find f of k. So what you need to understand and realize is that if a was positive, f of k is also positive. If a was negative, f of k was also negative. So what I'm trying to make you understand is the second condition can be that f of k and a have the same sign. And f of k and a have the same sign, their product will be positive. Because a and f of k are either both positive or both negative. Well, in that case, they should have the same sign. Third condition, there is a catch, there is a problem. I'm making an error. Can you help me in correcting that? The third condition will come with that catch, will come with that error, will come with the correction of that error. That error is, sir, do you not think that if you're thinking that k is greater than beta, even if I put k here anywhere where k happens to be less than alpha, there also f of k and a will have the same sign. If I put k somewhere here, f of k and a will have the same sign. So if I apply these two conditions only, in that case k will be either greater than beta or less than alpha. But what do we want? We want k to be lying on the right hand side of beta, not on the left hand side of the alpha. So for that, I have one pole. If I apply that pole and if I put one more constraint, I will ensure that k is always greater than beta, k is not less than alpha. There I'm taking this assumption that alpha is less than beta, alpha is the smaller root, beta is the greater root. Or even if both of them are equal, I am wanting to ensure that k lies on the right hand side of alpha and beta on the number scale, right? So here, if I were to say very simple part that if I want to keep k on the right hand side, I have a segregator here. Exactly between alpha and beta, the vertex lies, and that point has the x coordinate as minus b by 2a. Exactly between alpha and beta, the vertex lies, and that point is minus b by 2a. That x coordinate of that point. Which means if I ensure that k is greater than minus b by 2a, have I not ensured that k lies on the right hand side of beta only? Because now k won't be lying in this portion. Because if k lies in this portion, in that case f of k in a will not be having the same sign. So that condition has already ensured that k lies either here or here. But the next condition, when I say that k is greater than minus b by 2a, I have ensured that it is always greater than beta. So these three conditions, students, are always sufficient to ensure and say or claim that k, there is a number which is greater than alpha and beta. I hope this part is very well understood by you all. If there is any confusion, please let me know. But I think this is very well understood by most of you with a complete clarity. If there is any confusion, don't worry. We'll be discussing a lot of cases based on location of roots. You'll start getting more clarity with the upcoming more conditions, more situations, more scenarios. So don't worry about that. You will start getting more clarity. Let me say that let's take another example, another scenario where I say that let's take the opposite of it. What do I mean by that? That both of the roots of f of x are greater than k, which means k should be on the left of alpha and beta. So again, two cases will be there, either upward facing parabola or downward facing parabola. Let's say the roots are distinct or equal, but they should be real. So the graph will be either touching the x-axis or intersecting the x-axis. But I'm drawing the only graph where it is intersecting the x-axis. But we are considering the case where graph is touching the x-axis. Now, in that case, this is alpha, this is beta, this is alpha, this is beta. Now, can you help me with the scenarios, students? First case, for the existence of real roots, the discriminant should be either greater than or equal to 0. That's the first case. That is something you need to think of. Can you help me with the second case, students? What would that be? Second case, again. Where do I want k to be placed at? I want k to be on the left of alpha and beta. I want k to be placed on the left of alpha and beta. Again, in this case, a was positive, and I can clearly see that f of k is also positive. In this case, a was negative, and I can clearly see that f of k also lies below the x-axis, which means f of k is negative. Second logic will still hold true, that a and f of k will have the same sign. Either both of them are positive or both of them are negative. But again, as we have already discussed, if these two conditions are applied, then k could lie here as well, k could lie here as well. That's a problem. So I need to use the segregator, the differentiator, the pole. So what is the pole? The pole is minus b by 2a. So there is a point exactly lying between alpha and beta, which is minus b by 2a. So in the previous case, we applied the third condition that k should be greater than minus b by 2a. But in this case, I'll be applying the condition. Can you help me with that? Yes, k should be less than minus b by 2a. So if k is less than minus b by 2a, I have ensured that it is lying on the left of alpha and beta. That is, k is less than alpha and beta. Did you get that logic? I hope you are able to understand it more clearly now. If the first case was not very well understood, this particular second case is giving you more clarity, more in-depth understanding, right? Now, Let us look at the third case. Now you'll start developing the cases. So I'll give you the condition only, that what is needed to be done, and then you help me with what are the constraints which are need to be applied. Don't look at the solutions which I have provided. You tell me what should be done and why should it be done. I'll be really happy. So here, let's say I am told that k should lie between the roots. So in this case, k should lie between the roots. Well, how can you make that happen? So here it will be either upward facing parabola or downward facing parabola. One thing is assured here. I want a number to be lying between these two numbers, alpha and beta. So alpha and beta should be real and distinct. This time I cannot afford them to be equal. Are you getting my point very clearly? So first of all, D should be greater than 0 because I want something to lie between them. So to have some space, to make something lie between them, alpha and beta should be distinct, should be separated, and they should be real. There should be their existence, right? So there will be alpha and beta. There will be alpha and beta. In both the cases, either you are having upward facing parabola or downward facing parabola, but in either of the cases, alpha and beta should exist distinctly, which means discriminant should be greater than 0. Are you all able to think like this? I hope you are able to deduce such conclusions. The second conclusion, I want k to lie between alpha and beta. So if I want k to be lying between alpha and beta, k, I hope is giving you complete clarity. Here f of k is negative. In this case, f of k is positive. So now a and f of k are opposite in sign. When I had a to be positive, f of k was negative. When I had a to be negative, f of k was positive. So a and f of k will have opposite sign, which means a and f of k will have their product to be negative. These two conditions are always necessary and sufficient to ensure that there is a number k which lies between the roots alpha and beta. I hope you are able to deduce it. How many of you were able to get this particular part? Let's talk about the next part. Let's say it says exactly one root lies in the interval k1 and k2. So I'll take k1 and k2 somewhat like this. Let's say this is the case where again we have alpha and beta two roots. But here let's say this is k1 and this is k2. Right, this is the case when a is positive. Or what else could have happened? Let's say this is the case where you have alpha and beta. Let's say in this case I'm taking k1 to be here and I'm taking k2 to be here to make you understand the different case, right? And in this case we know that a is negative. Now again the logic remains very simple, students. First of all, I want exactly one root. For exactly one root, do you not think that discriminant should be positive? Because if the discriminant is positive, you will have two roots separated, alpha and beta, real and distinct roots. Because exactly one root I want to lie between a specific interval, k1, k2, right? Now, if you pay attention here, what is f of k1, students? I hope you are noticing f of k1 is positive. What is f of k2 here, students? I hope you are noticing f of k2 is negative. Pay here attention. So f of k1 in this case will be, I hope you are seeing, positive, and f of k2 in this case will be, I hope you are paying attention, will be negative. So did you get this particular part, that f of k1 and f of k2 are opposite in sign, no matter what the case is? So here also and here also f of k1 and f of k2 are opposite in sign, which means their product will be negative, and this is again the necessary and sufficient condition to ensure that exactly one of the roots lies between k1 and k2, these two numbers. I hope you are able to deduce it. Are you able to develop such logics? Even if not, if you are not able to develop, were you able to understand it after my explanation? I hope you are able to get these parts where we are understanding these things very clearly. Well, if you have understood so far all about location of roots, although there are certain terms yet to come, but as of now, let's revise whatever we have studied with the help of this example asked by JEE Mains in 2023. What does it say? The number of integral values of k for which this equation has one root lying in the interval 1, 2 and the other root lying in the interval 2, 3. Now, the problem is actually not a huge one. It is very much simplified. For your help, you are already told what is the coefficient of x square. There you have actually gotten a lot of clarity. See, the coefficient of x square is 2 And if it is 2, I know it very clearly that it will be an upward facing parabola. Second thing, I want one of the roots to be in 1, 2, the second root to be in 2, 3. So two roots should be real and distinct. That's all I think. So first of all, let's get more clarity about the quadratic. I know this quadratic will have an upward facing parabola. And when you say that it should have an upward facing parabola, let's say first root is alpha, second root is beta. First root should lie between 1 and 2 and second should root lie between 2 and 3. I hope this is exactly what we are told. I know a lot about this particular expression, and all I'm able to draw, because this 2, which is the coefficient of x square, is greater than 0. So it will be an upward facing parabola, and I want two distinct roots to be lying between 1 to 2 and 2 to 3. Hence, first conclusion will be discriminant should be 0. Greater than 0, I'm really sorry. First condition will be discriminant should be greater than 0. What will be my second condition? My second condition will be, what can you say about f of 1, students? Can you think something here? I hope most of you must have noticed f of 1 is lying above the x-axis, which means second condition will be f of 1 should be positive. What about the third condition? F of 2, can you make some comment over it? F of 2, students, I hope you are realizing f of 2 should be negative. I hope you are realizing nothing needs to be memorized or crammed or mugged up. All what you're given is needs to be understood. Once you have understood, things are easy. So develop the logic. This exam talks about the logic. This exam helps us in understanding how intelligent we are, how logically sound we are. So your basic intelligence is being assessed, nothing else. Trust me. Now, let's talk about the fourth case. The fourth condition will be f of 3, and I hope you can help me in understanding f of 3 should be, students, positive. So these are the 4 conditions I'll be applying and getting the answer. But of course, after taking the intersection of these 4 conditions only, that will be my final conclusion. So D, what is D? B square minus 4ac. What is b square minus 4ac? 64, right? Minus 8 square is 64 minus 4ac. So 4 into 2 into k, that is minus 8k. And I want this discriminant to be positive. From here, I can conclude that 8k should be less than 64, which helps me in understanding that k should be less than 8. That's your first conclusion. That's your first conclusion, students. I hope no confusions on that. That first conclusion is k should be less than 8. Let's talk about the next case. F of 1. Replace x by 1 over here. So what will be f of 1? F of 1 will be 2 into 1 minus 8 into 1 plus k, and f of 1 we want to be positive. From here, I can very clearly see 2 minus 8 is 6 minus 6. So k should be greater than 6. So that's your second conclusion, that k should be greater than 6. Third condition. I hope most of you must have started noticing that we have very gradually coming to a conclusion now. Let's talk about, even from here only you can start seeing the solution, but if you are not noticing it, let's work on f2 and f of 3 as well. What do I want? I want f of 2 be negative. So the next case, when I say f of 2 be negative, 2 into 2 square, which is 4 into 2, which is I think 8. 2 into 8, which is minus 16, plus of course k, and f of 2 should be negative. So this is what should be given. Now what do I do next? I hope I'll keep k here. This is minus 8. So here again I'm getting the same result. K should be less than minus 8, which we have already taken. So I'll not consider this part. F of 3 should be positive. F of 3 means 3 square is 9. 9 into 2 is 18. Then 8 into 3, which is minus 24, plus you have this k, and this should be positive. I'm really sorry, this should be positive. From here I can deduce that k should be greater than 6, which again we have deduced here. So I have two conclusions only. K should be greater than 6, k should be less than 8. What am I asked? I am asked the integral values of k. Now think of this like this, that k should be greater than 6 and less than 8. That's our final conclusion. I want the integral value of k lying between 6 and 8. That's only one value. What? 7. So k has only one value, integral value lying between 6 and 8, which is 7. So how many values of k are there? 1, which is 7, for which this condition gets satisfied. Did you all understand this? And if you have understood this, let us proceed further with more clarity towards some more cases. Let's say this case asks you that if both the roots are confined between k1 and k2. Now, without looking at these conclusions, can you help me in drawing these conclusions? Both of the roots should lie between k1 and k2. So again, either you will have an upward facing parabola or downward facing parabola. In the upward facing parabola, you have a positive. In the downward facing parabola, you have a negative. When it is upward facing parabola, either you will have two distinct roots or equal roots. In the downward facing parabola, you can have either two distinct roots or two equal roots. Real, of course, in both of the cases. But I'm drawing the scenario for the distinct one, real for equal ones also, the graph will be touching the x-axis. So that can also be drawn, but that may confuse you right now. So I'm drawing these two cases only. So let's say this is alpha, this is beta. Here also, this is alpha and this is beta. What do I want? I want both of the roots, whether equal or distinct, to be confined between k1 and k2, which means k1 needs to be here and k2 needs to be here. I'm assuming that k1 is less than k2, and here also k1 needs to be here and k2 needs to be here. Can you help me with this part? I hope the part is very well understandable. That first of all, those two roots exist. They must exist, whether equal or distinct. So for their existence, first condition will be d should be greater than or equal to 0. Did you all get that part? Now, here in this case, you must be noticing f of k1 is positive. Here in this case, f of k2 is positive. So can I say a and f of k1, a and f of k2 have the same sign? So second condition should be a times f of k1, a times f of k2 should be positive, because here also a was negative, f of k1 was negative, a was negative, f of k2 was negative. Students commit an error here. What they do is they take the product of f of k1 and f of k2, and that's a problem. The problem is, if you take the product of f of k1 and f of k2 and you say that that will also be positive because f of k1 and f of k2 have the same sign in both the cases, then you're wrong. Trust me. What if k1 and k2 lie between alpha and beta? Did you see that catch here? If k1 and k2 lie between alpha and beta, f of k1 and f of k2 both will have the same sign, and in that case also f of k1 and f of k2 will generate a positive value, but that will not satisfy the condition. So that's a catch, that's a problem. Students commit that k1 and k2, if I want them to lie outside alpha and beta, in that case I cannot have f of k1 into f of k2 to be positive. Rather, I should have two distinct scenarios, a times f of k1 and a times f of k2, both of them should be positive. Did you get that part? Let us look at the fourth scenario. There is one more case, students. What is that case? Sir, are these three not sufficient? Yes, they are not. The fourth case will be, what if k1 and k2 both lie on the same side of alpha and beta? Well, in that case also, these three cases will be satisfied. So again, I'm used to use the segregator, the pole, the differentiator. So we know there is a point minus b by 2a lying exactly between alpha and beta. So I need to ensure that k1 and k2 lie on the left and on the right of minus b by 2a. So that should be the fourth condition, which now will completely, absolutely, fully ensure that you have k1 and k2 confining alpha and beta. Otherwise, k1 and k2 may either lie on the either side of alpha and beta, right or left, or k1 and k2 may lie between alpha and beta. So I need not ensure that. I need to ensure that alpha and beta are confined between k1 and k2, and that will be happening when these four cases are checked. So I hope you understood this part, that you need to be very cautious, very alert, very much attentive while solving questions based on location of roots. Let's talk one more case where we say that k1 and k2 lie between the roots. So this is opposite of what we have discussed. So this time again, I have two roots. Again, two cases. One, when a is positive. Second, when a is negative. The coefficient of x square basically I'm mentioning. But this time, what do I want, students? We want that k1 and k2 must lie between alpha and beta. So k1, k2. Here also k1 and k2. What is the mistake students may commit? They may say, sir, f of k1, f of k2 both are negative. F of k1, f of k2 both are positive, so their product should be positive. Again, a problem. Did you realize why? Because that can happen if k1 and k2 lie here. That can happen if k1 and k2 lie here. here. So no, we don't want that. What do we want? We want k1 and k2 lie between alpha and beta. And when would that happen? That will happen. See, f of k1 here. What is it? Negative. F of k2 here. What is it? F of k2 negative. So f of k1, f of k2 are opposite of what a was there. So a times f of k1 and a times f of k2 should be negative. You can check it here as well. What is f of k2? F of k2 is positive, but a was negative. What is f of k2? F of k1, sorry, it was f of k1, I'm really sorry. So let's write f of k2 now. So what is f of k2? It is positive where a is negative. So yes, a times f of k1 and a times f of k2 will be negative. I hope you're realizing which conditions are supposed to be taken and which are to be excluded, which are not to be taken, because there you may again create some ambiguity, some dilemma, some confusion. No, we should take the most appropriate conditions. Did you get that part? Let us move ahead with the two more important theorems, remainder theorem and factor theorem. Now, these are some very simple and standard theorems which are often used, but they play a very crucial role in solving a lot of questions. Because if you notice that there is a question which is being solved with the help of these particular catches, remainder theorem or factor theorem, then the problem becomes actually a little simpler and solvable. How? Let's understand with an illustration. For example, I'm given, let's say, an expression x square minus 5x plus 6. And let's say I'm told find the remainder when this is divided by x minus 1. Well, one of the methods will be I'll use the polynomial division, I'll solve it and then I'll get the remainder. So what am I asked? The question says x square minus 5x plus 6 when divided by x minus 1, what should be the remainder? Now, what does the remainder theorem say? Remainder theorem says that you need not do all this. What are you supposed to do then? I have this expression, right? X square minus 5x plus 6, right? And I need to find the remainder when it is divided by x minus 1. So what you do is put x minus 1 equal to 0. There you get the value of x as 1. And that x, which is 1, put here. So basically, if it is f of x, I need to find f of 1. So what will be f of 1? Which it will be 1 minus 5 plus 6, which is nothing but what? 6 minus 5 is 1. 1 plus 1 is 2. So again, if you do it through the longer method, that is, if you divide it by this, the remainder is going to be 1. Sorry, the remainder is going to be 2. Or even if you use this simpler method, this is going to be 2. So I hope you're understanding how is this remainder theorem getting applied in a lot of questions to find the remainder with such ease. Not just that, it does not stop here. It actually gets extended to factor theorem. Now, what do I mean by factor theorem? Let's say I have this expression x square minus 5x plus 6 and I'm asked to divide it by x minus 2 and find the remainder. So what will be the remainder when this expression is divided by x minus 2? That's again a question we are dealing with. Again, what will I do? I'll put x minus 2 equal to 0, from where I'll get the value of x as 2. And again, if we are told that f of x is equal to x square minus 5x plus 6, I'll find f of 2, which will be the remainder. When this is divided by x minus 2. So f of 2 will be 2 square is 4, 5 into 2 is 10, and this is 6. So 10 minus 10 is 0. Now, what is the important observation you are making here? That if f of 2 is 0, which means the remainder is 0. If the remainder is 0, which means this perfectly divides this, which means x minus 2 is a factor of x square minus 5x plus 6. Which means if I replace x by 2 here in this x square minus 5x plus 6, and if it becomes 0, then I can conclude that x minus 2 will be a factor of x square minus 5x plus 6. That's exactly what the factor theorem says. So I hope you'll utilize these results. And then with that, let us talk about a very important result, which is based on equations of higher degrees. Now, how do we deal with that? Let's say, first of all, let's talk a very important observation here. Let's say we have a cubic equation and we need to make some deductions about their roots. So we can draw some more conclusions based on what we are going to learn right now. Remember, this is a very important concept again. It is used at a lot of places, not only in quadratic equations, but in a lot of chapters where polynomial comes into picture. So now we are shifting our focus to the final topic, which is higher degree equations, where we'll talk about roots. and then some more conclusions related to higher degree equations with some illustrations, of course. So let's have a look at this particular part. Let's say I have a cubic, which is ax cube plus bx square plus cx plus d is equal to 0, right? Let's say this is the cubic and it has three roots, alpha, beta, and gamma. Now they can be real, imaginary, or whatever, I don't know, but it has three roots. Now I can draw some very important conclusions on these three roots. First conclusion, the sum of the roots. Alpha plus beta plus gamma. Well, sum of the roots alpha plus beta plus gamma is always given by minus b upon a. I repeat, it will be given by minus b upon a. So I used b and a, their ratio, and then I took the negative of it. What if I take sum of the roots taken two at a time? What does it mean? It means alpha beta plus beta gamma plus gamma alpha. What will it be? Sum of the roots taken two at a time will be c upon a. So here the sign negative did not come because sign keeps on changing alternatively. So initially if I started with negative, it should be positive. So the next one will be negative. So if I take sum of the roots taken three at a time, so there are only three roots, so their sum won't be there, it will be just product of them, alpha, beta, gamma. Well, it will be minus d upon a. So did you get that part? Well, its generalized version is given over here, but you need to understand the algorithm, the process. This will help you in cracking it better. I'll try to give you more clarity with one more example so that you can apply them wherever questions are asked. Sequence and series, a lot of chapters are there which use polynomials, and there you may have to deal with these kind of, expressions. Sum of the roots taken one at a time, two at a time, three at a time. A lot of concepts are there in a lot of chapters where these polynomials play a crucial role. So you need to be aware of it. Let's take one more example and let's see whether you are able to crack it or not. So this is a polynomial in degree 4. A have ax to the power 4 bx cube plus cx square plus dx plus e is equal to 0. Of course, since it is a polynomial in degree 4, it will have maximum 4 roots. They can be real or imaginary, whatever. We don't know anything about that. But if it has 4 roots, let's say alpha, beta, gamma, and delta, what conclusions can be drawn about those 4 roots? First, sum of the roots taken one at a time. It can be written as summation alpha. What does summation alpha means? It means alpha plus beta plus gamma plus delta. So it means sum of the roots taken one at a time. Well, it will be minus b upon a. Did you get that part, students? Now, I'll come to the next part where I'm saying sum of the roots taken two at a time, which means alpha, beta, alpha, gamma, alpha, delta, beta, delta, gamma, delta, sum of all these roots taken two at a time. Well, it will be, I hope you must have cracked it, negative b upon a. So the next should be plus c upon a. I hope you have started seeing the pattern. The third one, sum of the roots taken three at a time. For example, alpha, beta, gamma, delta, beta, gamma, delta, so on, like that. So if I take the sum of the product of three at a time, then it should be, I hope you're realizing, minus d upon a. So I hope you have started seeing the pattern. I hope you are noticing this. Next part will be sum of the roots taken 4 at a time. So I need not write it like this, sum of alpha, beta, gamma, delta, or rather it will be alpha, beta, gamma, delta only because there are only 4 roots. Previously it was minus d by a. So now it should be, I hope you can predict it by looking at the pattern, it should be plus e by a. Did you get that part very easily, students? I hope it's perfectly understandable that how does this make sense, and we are able to get this part very easily. Well, there are some more conclusions which we are able to draw based on equations of higher degree. So not always you are supposed to solve equations of higher degree, for example, cubic, biquadratic, pentic and all, but a lot of observations are needed. By looking at those equations only, you can make a lot of conclusions. Now, what are those conclusions and how should you apply them while solving questions of mains and advanced? Let's learn those concepts. Then we'll learn how can we apply them by solving certain questions. Have a look at this part. So whenever we are given a polynomial of degree n, it will have n roots. So if this is a pentic equation, it will have 5 roots. They can be real, they can be imaginary, number of real, number of imaginary, that we'll discuss later. But if there is a polynomial of degree n, it will have n roots. Roots means solutions, means the graph will cut the x-axis at those points. It may cut, it may not cut because the roots can be imaginary. In that case, the graph may not cut it, but these many roots will be there, real or imaginary. But total, those number of roots will be there, whatever the degree of that polynomial is. That is sure, that is bound to happen. Well, what do we know next? If all the coefficients are real, then imaginary roots occur in pairs. So if the polynomial real is being talked about, so far we haven't talked about complex polynomial, nor we want in this particular lecture. So if I am given a polynomial which is a real polynomial, that is coefficients are real, well, in that case, the imaginary roots always exist in pair. The imaginary roots always exist in pair. That's a very important conclusion you need to remember. For example, if there is a cubic, so cubic may go like this. If there is a cubic may go like this. Now, why am I drawing its graph like this? Please understand, whenever you have an odd degree polynomial, whenever you have two conclusions I'm mentioning here, whenever you are having an odd degree polynomial, or sometimes you may deal with even degree polynomial. So whenever you're dealing with an odd degree polynomial, it has its range from minus infinity to infinity. That means it will take all the real values. But if you are having an even degree polynomial, it will have the range from minus infinity to something certain, or from something certain to infinity, but it will not have the range from minus infinity to infinity. Which means, what I'm trying to make you understand is, the graphs of odd degree polynomials will lie between minus infinity to infinity with respect to the y-axis, but the graphs of even degree polynomials may not. What I'm trying to make you understand is, let's say, again, I'll come back to this point. Let's say there is a cubic polynomial. So cubic polynomial may have a graph like this, which will lie between minus infinity to infinity. And of course, if it is intersecting the x-axis at 3 points, then these are the 3 real roots this cubic has. But let's say if it happens to be a biquadratic, a polynomial in degree 4, let's say somewhat like this. And in this case, you may notice that this is how the graph may be drawn. I'm not saying this is exactly how it will be drawn, but this is how the graph may be drawn. Or if not like this, let's say in some other case, the graph may be drawn somewhat like this perhaps. So in this case, what you all should notice is that it was coming from plus infinity. It reached a certain minima. Let's say this is a certain value, but it will not reach up till minus infinity if it is an even degree polynomial. So whenever there is odd degree polynomial, it will lie between minus infinity and infinity in terms of range. But if it is an even degree polynomial, it will have a certain minima up till infinity, or it will have a certain maxima from minus infinity. So this is how graphs are drawn or understood or taken. All of this which I'm mentioning here, we'll discuss in very much detail when we discuss the concept application of derivatives. A lot gets decided based on it, because what I'm trying to make you understand is, let's say I'm dealing with a cubic. I'm dealing with a cubic somewhat like this, ax cube plus bx square plus cx plus d. So a lot gets decided by the coefficient of x cube. If the coefficient of x cube is positive, the cubic will come from minus infinity and it will go to plus infinity. But if the coefficient of x cube was negative, it will come from infinity and go to minus infinity as we move on the x-axis from left hand side to right hand side. These are some observations which I'm giving you. I hope you are understanding them. Just learn them, keep them in mind, and whenever you get the opportunity to use them, apply these observations on the questions asked on higher degree equations. Similarly, let's say I'm having a even degree polynomial. For example, ax to the power 4, bx cube, cx square plus dx plus e, right? So if a is positive, then I'll see it to be like this, which means it will have its certain minima, but it will go up till infinity. But if a is negative, what do I mean by a? The coefficient of highest degree term, x to the power 4. If a is negative, well, in that case, it may go somewhat like this. Which means it will come from minus infinity. It will reach or attain certain, maxima, but it will go back to minus infinity. So even degree polynomials start with minus infinity and go back to minus infinity, or start with infinity and go back to infinity. But odd degree polynomials either start with minus infinity and end at plus infinity, or start at infinity or reach up till minus infinity. So that's the difference between odd degree polynomial and even degree polynomials. I hope you are getting that conclusion. Now, I'll talk about the number of real roots and imaginary roots. See, with whatever we have discussed so far, I can say a lot about the roots. You need to remember that whenever you're dealing with an odd degree polynomial, it goes from minus infinity to infinity or plus infinity to minus infinity, and polynomials are always continuous functions. So if you are drawing a graph, the graph of any odd degree polynomial, and if you want to take it from minus infinity to infinity, then it is bound to happen that the graph will intersect the x-axis at least once. Which means if it is going from minus infinity to infinity, the graph will intersect the x-axis at least once. And if it is intersecting the x-axis at least once, which means if the degree of the polynomial is odd, it will have at least one real root. It will have at least one real root. But as we have already discussed, that imaginary roots always occur in pair. We have already discussed if there is a real polynomial, imaginary roots occur in pair. They are conjugate of each other, which means if one of the roots is 2 plus 3 iota, there will be another root 2 minus 3 iota. So if there is an imaginary root which is occurring in pair, which means if even degree polynomial is there, which means it will have even roots. And if roots are occurring in pair as far as imaginary roots are considered, then there are chances that an even degree polynomial may have zero real roots. I hope you must have seen it in quadratic. Let's say I'm dealing with a quadratic. Ax square plus bx plus c, right? This is a quadratic. Now, if one of the roots is imaginary, the other root will also be imaginary because it is supposed to be its conjugate. So if you are dealing with an even degree polynomial, it may have zero number of real roots. But if it is an odd degree polynomial, it is supposed to have at least one real root. Well, let's talk about some more conclusions, some more important observations we are supposed to learn by observations based on polynomials. What are those learnings? Let's have a look at them. Every equation of an odd degree has at least one real root. We have discussed it. But one more conclusion can be drawn, that this root has a sign opposite to that of its last term, given that the coefficient of first term is positive. What I'm trying to make you understand is, let's say there is an example, 3x cube plus, let's say, 2x square minus 7x minus 10 is equal to 0. So this is a cubic. So we know that there will be one real root, at least one. There is a possibility that all the three roots could be real. I'm not saying anything about that. I am saying that since it is a cubic, it will have at least one real root. And if it has at least one real root, that real root will have a sign opposite to the last term. So if the last term is negative, that one real root will be positive, provided that the coefficient of the highest degree term is positive. I hope this part is very well understood by you. These are some basic observations which you should remember. If you learn them, you may be able to use them during questions and find some important deductions based on the questions. Similarly, we can draw some more conclusions, such as that if there is an even degree term, if there is an even degree term, then we can always conclude that it will have at least two real roots. When it will have two real roots, one positive and one negative, whose last term is negative, provided that the coefficient of the first term is positive. What do I mean by that? I'll explain it again with an example. Let's say x to the power 4 plus x cube minus 2x square plus 7x minus 8 is equal to 0. Let's say this is an even degree polynomial. Degree 4, which means even, coefficient of x square is 1, which is positive. And now what I know is the last term is negative. The last term is minus 8, which is negative. So this will have four roots, of course, alpha, beta, gamma, delta, out of which two roots will be real, first of all, and they'll be opposite in sign, which means if alpha is positive, beta will be negative. If beta is positive, alpha will be negative. This is also something which you should remember. These are some common conclusions I am explaining as of now. I'm not going ahead with their explanations or derivations. I'm just giving you these conclusions. Remember them. They'll actually help you a lot in deciding a lot of things. The next conclusion: if an equation has no odd powers of x, then all roots of the equations are complex, provided the coefficients of the equation have positive sign. What does it mean? Let's say again, I'm given an equation x to the power 4 plus x square plus let's say 8 is equal to 0. This equation has all the powers of x even, power 4, power 2, power 0, and the signs are positive, plus, plus, plus. Then you can always deduce that this will not have any real root. Think like this. No matter what value of x you put here, they will be non-negative. So non-negative, non-negative plus 8, it can never be 0. If I want it to be 0, well, that can be done with the help of complex numbers only. Because when you wanting to square something and you want something to be negative, that can be done with the complex numbers only. So here, if a equation with even degree is given, where all the powers of the variables are even only, no odd powers are there, and the signs are positive only, plus sign are there, then it will never have real roots. It will always have complex roots. I hope you're getting this part very clearly. Now, Descartes' rule of sign says very interesting thing. What does it say? I'll make you understand it with again a very simple example. Let's say you're given a cubic. 3x cube minus 7x square minus 8x plus 10 is equal to 0. So by looking at the cubic, you can make some deductions. What are those deductions? The number of positive roots of a polynomial arranged in decreasing order of the degree cannot exceed the number of changes of sign in fx as we move from left to right. Descartes said something very amazing. This is again which may not give you the complete idea about the roots, but it will give you a lot. It will say or make you understand a lot about a polynomial. What does it say? It says you first of all arrange it in the ascending order, decreasing order of the degree, first of all, cubic, square, 1, and then the constant term. And observe the change in sign. What do I mean by change in sign? Well, the change in sign means plus 2 minus first change, minus 2 minus no change, minus 2 plus second change. So there are two changes in sign happening over here. What does it mean? The number of changes in sign actually gives you the idea that if there are two changes in sign, then the positive roots will not be more than 2. Which means I can say that fx will have maximum positive roots 2 only. The number of maximum positive roots of this particular equation will be 2. I did not say it will have exactly 2 positive real roots. No, I did not say that. What I'm saying is this equation cannot have 3 positive real roots. That can always be said. Well, Descartes' rule can be used in some more conclusions. What are those conclusions? Let's say in this f of x, I replace x by minus x. I am writing, let's say, f of minus x. What will be f of minus x? It will be minus 3x cube. Then I'll have minus 7x square. Then I'll have plus 8x. Then I'll have plus 10 is equal to 0. What does it mean? It means, again, if I observe the change in sign, negative, negative, no change. Negative, positive, first change. Positive, positive, no change. So how many change in sign happening? 1. When x was replaced by minus x. That gives you the maximum number of negative real roots it can have. So number of negative roots a polynomial degree can have are going to be maximum 1 because there is only one change in sign. Did you understand that Descartes rule, students? Are you able to get this idea that how are we using it? Well, with that, whatever we have discussed so far regarding polynomials, let's get more clarity with this example asked by JEE Mains in 2023. Very good question, very amazing question, a very insightful question, a very comprehensive question. It will give you a lot about biquadratic, high degree polynomial, logarithm, and a lot more, and how should you deal with graphs, and a lot can be deduced with the help of these questions. So this is one of those questions which is good, which will help you in understanding a lot of concepts. So this, I think, will give you a lot clarity. First of all, let us understand and let us observe this. I have e to the power 4x, e to the power 3x, e to the power 2x, e to the power x. So I am dealing with a polynomial which has the variable e to the power x. So as of now, to keep it simple, can I not take e to the power x as t? Just to keep it simple. So to keep it simple, I have written as e to the power x to the power 4, which is t to the power 4, then 8 e to the power 3x, which is 8 t cube. then 13e to the power 2x, which is 13t square. Then I have 8e to the power x, which means 8t. Then I have this constant term, which is 1 is equal to 0. So this is what we are now dealing with. Something very interesting needs to be observed in this category of questions is there is a specific method which you need to learn here. I am dealing with a equation which has degree 4, which is even. What you should start noticing is that if I look at the pattern, the coefficients of highest degree term and lowest degree term is 1, which is same. The coefficient of the second highest degree term and the second lowest degree term is 8 and minus 8, which is numerically same. The coefficient of the third highest degree term and the third lowest degree term, which is t square only, is 13, which is also same. Well, there is a certain method which you can apply or think of. What is that method? The method is very simple, students. What you need to do here is, it is t to the power 4. Divide this entire expression on both the sides by t square. We already know t cannot be 0 because t is e to the power x. We already know e to the power x, when the graph is drawn, goes like this. So e to the power x always lies above the x-axis. So e to the power x will not be 0, which means t will never be 0, which means I can always divide it by t square on both the sides. So if I'm dividing it by t square on both the sides, what do I get? I'll have a t square here. Then this part I'm writing further. So 1 when divided by t square becomes 1 by t square. So that part I'm writing here. I don't know why. Then I have this 8t cube when divided by t square leaves you with 8t. So I'm keeping that t inside and putting that 8 outside. This minus 8t upon t square will leave me with minus 8 upon t. That 8 is taken outside. So I'm getting t minus 1 by t here. If I club this and this term after division by t square, the final term 13t square by t square, well, that will be 13 is equal to 0. So what I have done here is I have clubbed this and this after dividing by t square, this and this after dividing by t square, and this after dividing by t square. I hope no confusions on that. But what is the advantage of this? Why are we doing all this? Forget all this. Let's look at this particular part. For a while, let's say I replace t minus 1 by t by k. Again, I'm using another, replacement. So if I replace t minus 1 by t by k, can I say if I square both the sides, this will be t square, this will be 1 by t square, this will be 1 by t square minus 2 into t into 1 by t. So t into 1 by t will be 1. So I'll be left with minus 2 is equal to k square. From here, are you not able to draw another conclusion, a very important conclusion, that is t square plus 1 by t square is equal to k square plus 2. Did you get that part? If you have noticed something very interesting, we have solved this problem to a very great extent. Why? Because t square plus 1 by t square can be substituted by k square plus 2. So the problem now looks like k square plus 2 plus 8 times t minus 1 by t we are supposed to take as k, and there you have this 13 is equal to 0. So this is how easy this has become, which was something really unsolvable for us. This is a quadratic, right, students? And this is something we are able to solve. So if I solve this, k square plus 8k, 13 plus 2 I think is 15. So k square plus 8k plus 15, right? So we have this as k square plus 8k plus 15 is equal to 0. Splitting the middle term will help us, I think. So 8 is 5 and 3. 5 into 3 is 15. So splitting the middle term is actually helping us. So k square plus 5k plus 3k plus 15 is equal to 0. That is what we know so far. Now, what do we have next? The next part is the values of k. So one of the values of k will be minus 5. The other value of k will be minus 3. Well, these are the values of k. Although k was t minus 1 by t. I hope you're realizing it. So if I replace t minus 1 by t by minus 5, I'll get another quadratic. And if I replace t minus 1 by t by minus 3, I'll get another quadratic. So two quadratics we are supposed to solve. How do we do that? See, I'll multiply both the sides by t. So this will be t square. Then I have minus 5t, which when brought on the left hand side will give you plus 5t. And this will be minus 1 is equal to 0. Here when you multiply it by t, it will be t square. Minus 3t will come on the left hand side, will make it plus 3t. And this will be minus 1, which is equal to 0. I hope this part is understandable. From here, I draw one more conclusion that I don't think it can be splitted. So I'll use the Sridhar Acharya formula. What does it say? From here, the value of t will be minus b, which is minus 5, plus minus under root over b square minus 4ac. So 25 minus minus 4, which is plus 4. So 25 plus 4 is 29 divided by 1. Sorry, 1 nahi, it should be 2a. So 2a is 2. I'm really sorry for that. T is equal to, here, minus b, which is minus 3, plus minus under root over b square, which is 9 minus 4ac. So minus 4ac, that is plus 4. So 9 plus 4 is 13 divided by 2a, which is again 2. Now, let us proceed further with the next part. From here, I'm getting 4 values of t, which is what we are supposed to, because t was e to the power x. Now, please pay attention to this part. I have taken e to the power x as t. I hope you are able to notice it. So we know that e to the power x is always positive for all the real values of x, which means I know that t will always be positive. T should always be positive, right? I need to ensure that t is always positive. Now, under root 29. I hope if you are realizing, if I take negative sign here, minus 5 minus root 29 upon 2 will be negative. Minus 3 minus root 13 upon 2 will be negative. So here, two values are already discarded. So I'm left with two values. Which two values? One of the values of t will be minus 5 plus root 29 divided by 2. And the other value of t will be, again negative sign is supposed to be discarded, 3 plus root 13 divided by 2. Now I need to check for these two values whether they are positive or not. So yes, let's check them. Root 29 is greater than 5, but root 29 is less than root 36, so it is less than 6. So this will lie between 5 and 6. So to solve it, let us take an assumption. Root 29, I'm assuming as 5.5. It may be 5.5, it may not be, it is an irrational number. But to solve it, I'm assuming it to be 5.5. 5.5 minus 5 is 0.5. 0.5 upon 2 is 0.25. So t is taking a value 0.25, which is an acceptable value because e to the power x needs to be positive, which is 0.25 approximately. Root 13 lies between root 9 and root 16. Root 9 is 3, root 16 is 4. So root 13 should lie between 3 and 4. Let's say 3 and 4, 3.6. Let's take a value randomly, 3.6. 3.6 minus 3 is 0.6. 0.6 divided by 2 is 0.3. So I have gotten two values, 0.25 and 0.3. And if you are in a rush, and if you are solving it further by looking at 0.25 and 0.3, and if you're marking that two solutions will be there and both of them are positive or no solution like that, then you are wrong. Again, you're supposed to solve it further where you need to take it that t is 0.25 and 0.3. Now let me talk about e to the power x. Please understand, we have the graph of e to the power x. This is the graph of y is equals to e to the power x. Let's, instead of y, I say this is t is equal to e to the power x. So this is t is equal to e to the power x. So on the y-axis, I'm taking t. On the x-axis, I'm taking x. Right. Now, the values of t are found to be 0.5, 0.25 and 0.3. Where do you find 0.25, students? We all know that this point is 0, 1. So here, let's say I have 0.25 and let's say here I have 0.3. Now, can you help me with these values? When do I have 0.25 and when do I have 0.3? So I'm really sorry, I have made an error because let me just correct this. This is not the value of x. 0.25 and 0.3 are the values of t. So I hope you know, if this is 1, I will have 0.3 and 0.25 here, although not very appropriately drawn to the scale, but just to make you understand, this will be 0.3 and this will be 0.25. So corresponding to 0.3 and 0.25, if you understand these things very clearly, this will be a value, and with 0.25, this will be a value. Let's say this is our x1 and this is x2. I hope you are understanding. I am solving for e to the power x1. E to the power x1 is equal to, let's say, 0.3, and I'm solving for e to the power x2 is equal to 0.25. So whatever I know so far, even if I don't know the value, I have to take the logarithm on both the sides to find the values of x1 and x2. But I know for sure is that x1 and x2 both are going to be negative because both of them are lying on the negative side of x-axis. both of them are lying on the negative side of x-axis. If both of them are lying on the negative side of x-axis, then I'll say there are two solutions and both of them are negative. A very insightful question it was. It has given you a lot of clarity how to use by quadratics, by substitution, then this part where t plus 1 by t and t square plus 1 by t square, or t minus 1 by t and t square plus 1 by t square are needed to be connected. And then applying Sridhar Acharya, e to the power x, logarithm, graphs, and a lot was clubbed in this particular question. So JEE Mains asks you some difficult questions as well. This was not needed to be done by you in the examination before you have done all the easy and moderate level ones. Then of course you should shift to this category of questions, but it was indeed a very good question. Well, with that, let's move further. Let's talk more about few more things where I'll say that the summary is we have discussed everything in detail. We have given you complete clarity in this one shot about quadratic equations. You know all the concepts. My request is we are providing you with the DPPs. We are providing you with the practice sheets, which is DPP. We'll be giving you test series and a lot more. This complete lecture, its notes in the PDF format, everything is provided to you at absolutely free of cost at our PW channel on our PW app. The link to that is already given in the description. JEE crash course in pure English is already there. Access that at absolutely no cost and use these features. This is a very amazing opportunity. This is an absolutely amazing opportunity you should not miss. With that, I think we can call it a day. Thank you so much, students. This is one of the homeworks I'm wanting to give you. This is a homework question I'm willing to give you before you leave. So before you leave, this is a bonus question I wanted to give you as a homework. Before you attempt it, I'll just give you a hint that whenever something like this is given to you, fx times f1 plus x is equal to fx plus f1 by x. We'll discuss this particular concept when we study functions. We'll study functional definitions and there I'll discuss this particular part. But whenever you're given something like this, you should always conclude fx as 1 plus minus x to the power n. That's my hint. Further, you're intelligent enough to solve this question. This is the part which you may not be aware of if you haven't studied functions so far, but rest of the things you can solve by yourself, and I'd love to know your answers. You can write in the comment box, sir, that the answer to the bonus question is this. I'll really love to hear from you all. So with that, I think we can proceed further and we can call it a day. So I hope you must have understood everything in detail, learned all the concepts, understood all the previous year's questions and illustrations and examples. You will do a lot of practice with the DPPs provided to you. Revise the notes. The PDF will be shared with you. Access all this content at absolutely free of cost with the link given to you in the description. I hope this is sufficient for the day. Thank you so much. Take a good care of yourself. You have been a great audience. Thank you so much.